we're getting an update of what they're doing.
You're about to get a great update, Dawn.
They're making.
I'm butting into your conversation.
Okay.
Yes.
Do what?
Are y'all ready?
No.
Yes, everybody's ready. So cab members, you're going to see 2 handouts at your seat. There's 2 additional handouts that you've received. One is your travel voucher. Please sign it, return it to Chelsea so that we can reimburse your mileage. The other one is a brief handout that looks a lot like that poster up there. It is a complimentary diagram that goes with your 235F presentation that Randy Clendenning is about to give. So if everybody's ready and we're settled in, all right, Randy.
Hello, my name's Randy Clendenning, and I'm the Federal Program Manager for the 235F Risk Reduction Project. The handout that I gave you, the last time I did this, I had that slide in the presentation, and I found I was having to go back and forth to it a lot, so I thought I'll just hand one out. It'll be useful as I talk through how material flowed through the facility and other things like that, I think, because that's kind of hard to see too. Like I said, I'm going to provide an overview of the risk reduction activities. That's a reasonably recent, well, it's not so reasonably recent picture of the facility. That stack is gone now. So a little bit of background. 235F was part of the original construction of the site in the early 50s. It's a blast-resistant, windowless, 2-story facility. It's 220 feet long, a little over 100 feet wide, 20 feet high, and the walls are 14 inches thick, nominally around the outside, reinforced concrete. It's in F area. The missions of the building over time have changed. Originally, it was designated a C line, and its mission was to take 239 metal and make triggers. That never happened. It was canceled before they installed any equipment. And after that, the building was reconfigured for some other missions. The first mission was the actinide billet line. That line produced billets, which are chunks of material that they make into targets that go into the reactor. But billets of neptunium-237, those were irradiated in the SRS reactors. And then from that, it was the plutonium-238 was separated out in H area, in the canyon B line. The next mission was kind of a precursor to PUF, the Plutonium Experimental Facility, the Plutonium Fuel Form Facility, and the Met Lab. They did proof of concept kinds of work and some a little bit bigger than benchtop, but some small scale kind of manufacturing testing of the process that what is now PUF, of making these fuel cells. Then in the mid-70s, 73 I think, they started construction. They started reconfiguring the building, and they modified the billet line and installed what is currently the PUF facility, that's where we're working on reducing the MAR. I think that was completed in 77 maybe. So what is, if you look at your little map, if you're holding it up like this, the actinide billet line would have been off to the left. And as I talk through this, the material would have entered through cell 1, which is at the top left, and then it would have just come down in numerical order basically through the cells. And I'll go through some pictures, not particularly good ones, but the best I could find, of what was done in the cells as it moved through there. So the process, the PUF process was, well, all the metallurgical processes within the building were shut down by 1990. And the final mission was storage of special nuclear materials at the site for the complex. But in 2006, all the vaults were emptied, and it's been maintained in a surveillance and maintenance mode since then. I think I mentioned This is a picture, I don't know the age, but from the clothing, I would guess it was a while ago. This is a picture of what the shift operations base looked like back when the facility was operating and there were people in there working. All the work was done remotely with manipulators through shielded windows, and then the cells were on the other side of that. So if you look at this, those folks would be standing in here. This is cell 1, so those guys would be that guy would be standing here. As I mentioned, the billets were manufactured. They were irradiated in reactors to eventually produce the plutonium-238. The plutonium-238 was separated and extracted in the canyon and the HB line, and the product, the 238, was separated and sent back to the PUF facility. When it came into PUF, it entered in cell 1 here and was processed through these cells, and I'll talk a little bit about, these are called wing cabinets. I'll talk a little bit about those too, but it basically moved this way, and then there's a tunnel that goes under the floor here over to this cell, then it moved this way and out. The end product of this was an encapsulated pellet of 238 that was used in RTGs, radioisotope thermoelectric generators that NASA used to power deep space probes. This is some components when I get to talking about presses and things later. This was the best picture I could find of some of the pieces, parts of the equipment that was in there. There was a press in the wing cabinet of cell 4 that took the material and pressed it into pellets. It was called the hot press. And these are the dies that were used for that. And then these are the punches that went down and through the dies to press the pellets. There were 2 versions of these pellets that were made. The early version was a sphere, about 250 grams. And this is an example of the early version. It's a dummy. And then it was clad in an iridium shell and welded. So that's an example of an early one, a sphere. The later ones were more of a pellet, and I've got a picture of an example of one a little bit later. But the same thing happened to that. It was a little bit smaller. I think it was around 150 some grams maybe. But it was welded into an iridium shell also. This I can't speak to. This is just some examples. This is what one of the pellets looked like. The reason this is suitable for these RTGs is because there's a lot of decay heat that comes off of it. And they can, through some thermocouples and things, build a device that turns that into electricity to power deep space probes. And I found this picture. I can't really talk to the science of how it works, but that's what one of those things looks like, as best I know. And that is the pellet that we made. This is an example. I think this is the Galileo probe, but this assembly went out on the ends. That's one of the assemblies, and that's one of them. Risk reduction. At the conclusion of the PUF mission in the late 80s, work just stopped. People left. The residual material that was left was last measured in about 2006. Those measurements resulted in an estimate of about 1.5 kgs of 238 remaining in the cells. In our nuclear safety space, when they do the hazards analysis for accidents in the facility, there's a scenario. I'll learn how to use this when I'm done. There's a scenario where you could have a seismically induced full facility fire that would generate very large doses on-site and large doses off-site also. So, as I said earlier, I think the building's currently maintained in safely in a surveillance and maintenance mode, but the objective of the risk reduction project is to reduce the plutonium-238 in the PUF facility as low as we can reasonably get it, but to get it less than 100 rem doses in that analysis. This is another picture. newer than the one I showed you before, the shift operating base, but it's looking from the other direction. So this would be cell 6, that would be cell 5. This is what it looks like today after we've gone through and we've removed the brackets around here. There's an couple outer panes of shielded glass. Then there was a water-filled cavity, and then there's the inner glass. So we've removed the outer glass and the water, and that's what it looks like today. So I'll go through, and I spent some time looking for pictures, and they were kind of hard to find really good ones that you could see. Part of the difficulty in planning for this project is we couldn't see in the cells. The lights were burned out, the manipulators didn't work. So we were taking our best, I wouldn't call it a guess, but our best shot at what was in there from talking to people who had worked there before, people that had knowledge, historical documents, and then some of the previous surveys and things like that. So in cell 1, this is an older picture of cell 1. This is cell 2, and that's more recently, that's about what it looks like now. But as far as what was done in cells 1 and 2, as I said, the 238 was introduced into the cell line through cell 1. There was an oxygen exchange furnace in there to enrich the O16 content and dry that and displace the 17 and 18 and the oxygen 17 and 18. And that was done to reduce the neutron fields. So that was done. The material was ball milled to extremely fine particles. The paperwork says it was down on the order of about a micron, really small. Then it was pressed into more of a pellet-sized particle, and then it was moved out of 1 and 2 and processed further in some of the other cells. Cells 1 through 5, which is the whole east side, were maintained. They were inerted, maintained in an argon atmosphere. Let me go back to that. Part of what plutonium-238 is a bad actor when it comes to attacking, in particular, aluminum and other things. The manipulator arms here are aluminum, and you can see there's some other pictures where you can see this a little better. Looks like corrosion on them. This is an older picture, so it's not as bad, but that's our ghost. But you can see the corrosion on them. And there's some other pictures a little later where there's a doorway that I don't know that it's aluminum, but the way it's corroded, it may be. In cell 1, the product came in basically a shipping container from the canyon. These are racks where those shipping containers would sit. These are glove ports with no gloves. There would have been gloves that would have been installed from outside, and they would have been protruding into the cell. But those were long ago removed and kind of a seal put over the opening. This opening goes back into a wing cabinet that I'll talk about a little later and show you. It goes off the back of cell 1. You can kind of see it in your picture. There were 2 on cell 1. There was a lot of there were processes and work that was done. If you're looking, there were processes that were done in this wing cabinet. This was called a maintenance wing cabinet. In cell 3, this is a small cell. There wasn't really any process kinds of activities that happened in there. There is an access point into the cell line from there. But in looking, initially we thought that might be a way to drag material out of the cells. But there's only one glove port, and it's just and there are shield doors on the outside, which I don't have a good picture of, but you can kind of see them on your little diagram here. But those shield doors are on the order of 8 to 10 inches thick. They're steel water-filled doors. They're very heavy, and by the time you open them up and you've got one, it's just very, very difficult for somebody to get in there and do any kind of work that would amount to much. So we decided that that wouldn't be optimal for trying to bring material out, so we'll end up bringing it back down to cell 1 and out through one of the locks down there. Cell 4. So the material from cells 1 and 2 made its way down to, it was ball milled, made its way down to cell 4, and it was heated, high fired, there were 2 different temperatures. The high fired was 1600 degrees centigrade, or low fired to 1200, and then it was mixed in a 60-40 ratio, and then it was pressed into pellets or spheres depending on the time frame. It was 150 grams. And then it came out of there and went to cell 5, which there wasn't a lot that was done in cell 5, but that's where they called it the rabbit. Material would go into here, and there was a conveyor device that would take it over to cell 6, so it would cross under the shift operating base over into cell 6. And there's the door that I was referring to. You can see the corrosion on it. And then, if you're wondering, that's what this pile of stuff is. That's what's already fallen off. And then that's a manipulator arm that at one point was all shiny and new. That's the current state. This is a older picture. It's one of the better ones we have, with the cell in a pretty clean state at that point. So the material goes over to cell 6, and I don't know when this picture was taken, but it's the best picture of any of them we have out there of anything in this facility. It's almost shiny brand new. But that is cell 6. This is where the material, the spheres came over here, and they were welded. Those iridium hemispheres were put down over the sphere, and it was welded. And this was so 1 through 5 were an argon atmosphere. This was a helium atmosphere in this cell when they were doing the welding. There's an access port outside of the cell line in cell 6 also, and that's the door to it's kind of like a little airlock that you would go through, but that's the door on the cell side of it. Again, manipulators. This is the other end of the rabbit where it would come out when we move over from cell 5. Cell 7, that was primarily so by the time, once it's welded, the plutonium is essentially encapsulated. So the contamination levels, as you might guess, from cell 1 through 9 go down as you move through the process. And once you get over to cell 6 and it's encapsulated, the plutonium is basically sealed. So when we redid the assays recently, we found very little contamination compared to the other cells on the west side in cells 6, 7, 8, and 9. But in cell 7, the pellets or spheres were decontaminated. This is what it basically looks like today. That's what it used to look like. And I tried to find pictures that were similar. These are, again, glove ports with no gloves in them. If you were working in there would be gloves hanging into the cell, and manipulator arms hanging down. Cell 8, they did decontamination also. And the interesting thing here, I'll show you, this is the more recent picture, this is the later one. These more recent pictures are taken after we've removed these shield windows that I was talking about earlier. There's an outer frame and a glass window about 8 inches or so of water. There's about 12 inches plus of shielding, counting the glass, the water. So we removed the outer glass and the water, and the inner glass is there. One of the things we learned, and part of the reason we couldn't see through it, is the water had stuff growing in it. And, you know, going into it, we didn't know whether it was necessarily in the water. We had taken some samples and didn't find much in the water samples, or whether it had just gotten on the windows and grown on the windows. So when we took, cell 8 was one of the first outer windows we took off, and we took it off, drained the water, and got everything out, and we let it set overnight, and the window dried. So that's what this is. We didn't do anything abrasive. We let it dry, and it didn't come off so easy. After that, when the window was removed, the very next thing we did is take some towels and wipe everything down, and the windows cleaned up a lot better. So I guess we should have seen that one coming, but we didn't. Again, you can see the comparison. The cells were reasonably clean and free of the problems you see on the east side in cells 1, 2, and some that you saw in 5 from the metals, some of the metals that were attacked by the plutonium. Cell 9. In cell 9, that was the final cell. They leak tested the final product, and the material exited this cell through, this is the recent picture, that's an older one, through an airlock. They're difficult to see. You can see the manipulator arms here, but that's part of the airlock in the old picture. You can see it better in the newer picture, but it went down and out, and that's how the material came out of the cell line. So the work we've completed to date, before I go through that, I'll explain these pictures because I've kind of been talking about them. This is a 3D picture of the east line. So this would be cell 1. These are the 2 wing cabinets. This would be 2, cell 3, and a wing cabinet 4, and a wing cabinet and 5. And there's a wing cabinet in the maintenance room, but it was never connected to the cell. So it's basically a new cabinet. It wasn't used as near as we can tell. The press that was in cell 4, where they actually fired these and pressed them into the pellets, this is the cell 4 wing cabinet. So cell 4 is up here on the other side of that concrete wall. This is the wing cabinet and all the stuff that went with that. And then this picture, you can kind of see down here, that's the wing cabinet, this one, coming off of cell 1. But this is this area they call the east maintenance, and that's where you would go. That's where we will go to access the back side of the cell line, the wing cabinets, and then it's not clear here, but we'll bring material down and then out through one of the wing cabinets on cell 1. There's a lock down there where we can actually bag it out and drum it, get it out of the building. So work completed to date. Because of the fire issues, we spent quite a bit of effort early on, immediately, removing all the transient combustibles, stuff that, paper, chairs, things that could be moved around easily that would burn, and just emptied the building of all of that stuff, unless it absolutely couldn't be. And then there was a program put in place to very rigidly control anything else that went in. We took the fixed combustibles and removed a lot of them. What we couldn't, we encapsulated or isolated with things like sheetrock's a good thing that you could do that with. If we had something, we could encapsulate it on both sides with sheetrock to reduce the possibility of it burning. Removed a lot of carpet, took a lot of doors out. We de-energized circuits that weren't needed for the deactivation work and the things we were going to do. We physically removed some equipment. There was a shop in there that had saws, drill presses, things like that. We just took it all out. There was a fire detection and alarm system that we put in. We were very deliberate in our selection of people that we went out to select to do this work. We intentionally went and targeted folks that had done high hazard work with hazardous isotopes before. A lot of them did some of the TRU work previously. So they were used to working remotely through gloves with plutonium and other high hazard materials. And we went through a training qualification process. We have a mock-up, which is kind of a mock-up of a glove box that during one of the cab tours, there's a lot of new folks, but at that point, some folks got to play in the glove box and actually got a feel for it's not that easy to do work through all of those gloves and stuff. But so we've got that. We've got procedures in place, our hazards analysis and everything to get geared up and begin the removal of the plutonium from the cells. Okay. Did I skip one? Okay, so additionally, work we've done, we revised our safety basis documents to allow work in the cells, intrusive work. Previously, they were written to prohibit that kind of work because there wasn't any reason to do it, and it also reduced the risk of anything going wrong in the facility, and it reduced some of the controls that you might have to put in place if people were working there. So there wasn't any reason to be working in the cells. So there were stringent requirements that were put in place to prohibit it. So we had to go revise those documents and the analysis that supported them to allow work in the cells. We removed, I believe I mentioned, the outer windows, which would be the windows you can see from the shift operating base on your little handout. We removed the outer windows so that we could see in the cells. And then when we went and did the enhanced characterization, I'll talk about that. We removed the windows so we could see, and then that allowed better planning and insight into what was in there, what we might have to remove, some of the documents that had to be put together and generated for remove this, decon that, because it looks like it can't be removed. But that fed into a lot of the planning, the detailed planning that happened. So we performed an enhanced characterization. We did new measurements of the plutonium holdup in the facilities using newer equipment. In the process, well, the old equipment was done using, I believe, sodium iodide detectors. These latest surveys were done using an intrinsic germanium detectors, which are much more precise in their measurement ability. So we would get much more accurate numbers. There's not as much error involved in calculating the plutonium holdup. One of the things that helped, though, is when they did it previously, they took the measurements through all of that shielding. The the glass on the inside, outside, all the water in between. So there was about, I'm guessing, 12 to 14 inches of shielding that they were taking the measurements through, which makes it harder to get good measurements. So with that removed, this is an example of what the counting equipment looked like. They had tables they could pretty precisely align with where they wanted to take the shots. They could set that's the detector right there. They could set the detectors up, and then some of the count times in the cells that had lower activities were fairly long, like several hours. So they would get it all positioned. We keep everybody out, and they just sit there and do its counting. We had SRNL work with the group to develop some special tools that could be used, given that you had to do the work in gloves in that environment that was kind of small and confined. So they came up with it kind of looks like a garden rake, some of it, but things you could reach and grab, like the grabber tools, except they're not plastic. They're stainless and other metals that are a little stouter than that, and things that might look like a garden rake that are long-handled tools where, you can only get in about half an arm's length. So you could get a hold of these and then reach and drag things, from one glove down to the other till you get down to where you could take it out of the cells. As you might guess, removal of this stuff is just going to be slow going and tedious. But there's nothing magic about it. It's just taking stuff apart, wiping stuff off, and getting it out. The hard part is the isotope is really ugly. So another thing they accomplished to date is they replaced the process HEPA filters, which is the filtration coming out of that area. And then we have completed the electrical and mechanical isolation of all the cells in the wing cabinets. So we've eliminated that as a potential risk to people working in there, because there's, as you could see from some of the pictures, there's degraded wiring and all kinds of things in there. And part of what we want to do is unplug it and take it out, so we don't have to worry about anything energized. They went through a very methodical process of identifying all the power sources, and that was interesting too. As you might guess, with a facility this old, they found a couple of surprises along the way. Something wasn't exactly as the print described it, so they had to pause and go back and investigate it and figure out what actually was there, then go change the drawing, change all the drawings and make everything correct, and then go de-energize it. But that is all complete now. This is an interesting thing that we got out, an example of an interesting thing we got out of this enhanced characterization, the measurements. With the computer software and stuff that's available now, they were able to take the actual radiation measurements and make, the way I think of it, is kind of the radiological equivalent of a topographical map. So it's kind of like a heat map. You can, and I don't have the units here or in front of me, but you can see the reddish areas, there's some yellow areas, there's some other colors that are on there that aren't easy to see on the slide. But as you might expect, a lot of it is on the floor of the cell, around, this is a filter, on the filters, but it's predominantly on the floor of the cells, which is kind of what you'd expect. But then you can also see kind of where it might be located, and it's not a big surprise. A lot of it's located where the equipment is that touched the material, or you know, processed the material. But it is helpful. I mean, that kind of validated what you would hope was the case. So the work planned is, there's a lot more to it than what it sounds like describing. Is basically over the course of this year into about the middle of fiscal year 20, we're going to be engaged in going into the cells and taking stuff out. Once, you know, we'll start down in cell 1. We'll start pulling out some of the bigger pieces of material. Then once and progress up to 5 and empty the east side first. And then once that's done, they've got everything pulled out. We have a special vacuum cleaner that we had the lab build for us that's a HEPA filtered vac that can work in there, and we'll put the vacuum in and then vacuum the material that couldn't be easily picked up or moved, and get that out. And then the final phase of that would be a wipe down. There is a fixative that we're looking at, and we're still doing some testing on it, that we may be able to use at the end of this to actually coat the walls to fix whatever contaminant is left to the walls. The issue with fixatives is we don't want to introduce anything in there that could contribute to the fire calculations. So it's got to be non-combustible. The other issue is it's got to be a fixative that is not going to be degraded by the plutonium that it's going to be containing. So we're currently doing some tests. The lab is doing tests on it. I don't recall the name. It's a commercially available fire coating or fixative, but we've got to do some testing to make sure that it'll work, and that we can also take credit for its working when the analysts go do their nuclear safety analysis. So that's in process. We'll be applying some of that to one of the cells on the west side, and they'll be doing some studies to try to determine potential degradation, and hopefully that'll work out for us, and that would be the last thing we would do when we think we've done everything else we can and removed as much as we can. Then we would decide, well, do we need to apply the fixative, and if we do, where? Because we probably wouldn't just go spray everything down, but we want to decide where we did want to go apply the fixative. There's also a couple of examples in cell, I think it's the wing cabinet in 1, where there's like a little sump, and that would be an example where we might just, like a 1 foot by 1 foot, we may just fill that sump up with grout. But those would be some of the things that as we get in there and start removing materials and then start doing some surveys to see, well, what did we accomplish with the stuff we hauled out, deciding what do we do next. But that would be some of the things that we might do. But so that's pretty much what's going to be going on over the next couple of years. The material will, the intent of the project is the material will come out, it will be assayed, it will be drummed, and it will be shipped to our rad waste area, packaged and ready to go to WIP when it can get there. We don't, when we get it into drum or we get it packaged and it leaves the building, our intent is that it's in a form where nobody has to do anything more than just load it and ship it. Well, they have to do some measurements, but our intent is to get it ready to go, so that when they can accept things to WIP, when they can accept it out the WIP and we're queued up for shipping it, we can get it out of here. I think that's it. Yeah, that's an older picture of the cell line, but you can see there's cell 1 again. So this would be the east side, and then cell 6 would be down at that end, coming back up to cell 9. But the manipulators, we removed the outer parts of the manipulators on cell 5, 4. Did we remove 3, Jeff? And 3. But other than that, we've left the manipulators alone. We were prepared to remove them, but we found out we didn't really want to unless we had to, and we found out we didn't need to. We also have a couple of spares, new ones that we bought at the beginning of the project, so because we don't have any reason to think any of them are going to work. So if we need the manipulators for some reason during a part of the material removal process or the reduction efforts, we do have the ability to replace them with new units if we need to do that. But our preference would be to just not bother with the manipulators at all unless we just have to. Questions?
Let's start on this side. Let's go with Don first.
Dawn Gillis, cab. A couple things. You talk about the true shipments. Do you know approximately how many shipments that this will generate?
No. Well, and I don't mean to be cavalier, but it depends. Because it depends on the loading that we can put in each of the drums.
Which isn't very much.
Well, we're working on trying to get approval to go higher than what would be the current loading. And if we can do that, it will take a lot less drums. So we're working diligently to minimize the number of drums and things that we have to ship out there, but we don't really know the answer today.
Okay. And the other one's more of a comment. When you stated earlier that the cells 1 through 5 were filled with argon.
Yes.
You never mentioned that when it was shut down in 1980 or whenever it was shut down, that the argon just wasn't maintained, and when the argon went away, that's why all the corrosion happened.
Yeah, they literally turned it off and left. Maybe a little bit more than that, but not a lot more. They didn't flush systems. They didn't evacuate stuff, and at some point they didn't maintain the inerted atmosphere. So the inerted atmosphere was a couple of things. When they went through and heated the initial oxide in the oxygen 16 rich atmosphere to try to drive out the oxygen 17 and 18, if they didn't inert the atmosphere, that would reverse itself. And the other thing it did is it eliminated a lot of concerns with fire in the cells because there wasn't any air.
And they also turned off the circulation in the windows is one of the reasons the windows got so dirty. The water in the windows got so dirty.
Yeah.
I have another comment, but I'm going to wait till the end for that.
Okay.
Joyce.
Joyce
gonna
Underwood,
tease
cab.
me,
My question is maybe for my own edification and that of my new cab members who didn't hear your previous presentation. This facility is the one that we're concerned that it will catch on fire or fall victim to an earthquake and then plutonium will get out, right? That's our concern here?
Yeah.
Okay, so with regard to your fixative, is that going to eliminate that problem or just like lessen it?
Well, I won't do anything about the earthquake.
Well,
But,
yeah,
but first, let me speak to the analysis that those numbers fell out of. That analysis presumes, to get to those numbers of REM, that the entire building vanishes all at once and the complete inventory of everything in it goes up in a puff of smoke at the same time. So there's conservatism built into it, but that's just the way the analysis was done. That's the way they do them. It's conservative. The fixative, well, removing all the combustibles does a lot to reduce the risk of fire. De-energizing components that you don't need, if the more energy you can remove, the further you reduce the risk of having a fire. We've taken things out of, we've removed about everything out of the building. There's not a whole lot left in there to burn except cable. Now, we haven't spent the money to go do a full-fledged analysis, because it could be when the nuclear safety analysts went and reanalyzed this, that scenario of the fire and earthquake and everything wouldn't be a credible scenario anymore. But in our mind, it doesn't make sense to spend a lot of money on that. At this point, we should wait until we get some of the material removed and see, until we've gotten a lot of the hazard removed, and do it at that point and see where we're at. It's relatively, well, it takes a lot of people, it takes time, so it's expensive, and knowing that answer now wouldn't really change what we plan to go do in the facility, so we think we'd be better off saving that money and spending it down the road. But I guess the answer to your question is, we believe that at the end of this, the dose that would result from all of that would be significant, would be less than 100 gram, which is part of the DOE rules that we give to our contractor for off-site doses, or for on-site doses that they have to design facilities to maintain it less than that. That's why our objective is to get to less than 100.
Okay, and I have another question that maybe you don't know the answer to. Why'd they just lock the door and leave it?
It could still burn.
No. I mean, you said that they just walked away. Why'd they walk away and not shut it down properly?
I could guess all day long on that one, and most of them probably wouldn't be very generous, but I don't know.
Oh, okay. Thank you. That's all.
Okay. Susan?
Susan Corbett, Cab. Thank you. So you said there's approximately, it's here, 1.5 kilograms left
Based on the 2006 measurements.
based on 2006 measurement?
We just completed a new round of measurements with the newer detection equipment, the more precise, the intrinsic germanium detectors, and we believe that the number should come in less than that.
So it's basically kind of spread all over. It's not in one place.
No, it's not really. Most of it is it's the biggest pockets. Most of it's in one, because that's where the powder came in, where it was ball milled. And then the other major pockets of material are where it was basically messed with. So in cells 1 and 2, most of the material is there. There's another bigger abundance of material in cell 4, where they ran the press and smashed it into the pellets. In cells 7, 8, and 9, there's almost, in cell 8 and 9, and I believe 7, but I'm not so certain about 7. In 6, 7, 8, and 9, there's almost no material. There's a little bit in 6, and in cell 8 and 9, there wasn't anything above the detection limits of their equipment. So almost all of it is on the east cell line, and almost all of that is in cells 1 and 2 and their wing cabinets.
Now, I understand that this is 238. It's very flammable. Is that correct? Very flammable, right?
No,
it doesn't catch fire?
It's not flammable, but it emits a lot. It has a lot of decay heat that it gives
right.
off.
Okay,
so it could
heat.
start a fire if there was flammable stuff around it.
It's not. There's no danger of criticality though from the mount.
It's not fissile.
It's not fissile. So it's just the heat that's generated from it that could.
Compared to almost all other isotopes, it gives off a massive amount of heat.
Right.
That's why it works for what they wanted to use it for.
Right, because it's mostly like used in like space travel and things like that to generate thermal
Yeah,
heat.
it was used for these electricity generators for space probes when you get to the point where you can't use solar panels.
Right. So do you know how much is in the budget for next year to continue working on it? Is there a line item for it? It seemed like there was.
This is an operating activity.
Okay.
And the budget for next year is around 500,000 maybe. Jeff?
Next at DOE, I believe it's about $4 million.
About 4.
Mm-hmm.
Okay, thank you.
All right, let's swing around. Let's go to Dave Isley.
Dave Isley, Cab. I remember there was when Fix-It was first mentioned there was some controversy. Have you had any feedback or buy-in from both DNFSB and your regulators on that solution?
We haven't approached the regulators about the fixative because I don't believe there's anything that would drive us to do that. The board hasn't raised any issues, but part of those issues, I think, it would be premature, I believe, for them to have an issue until we get to the point where we've completed our testing and we even know if we think it's okay to use. But yeah, but so far nobody has brought up any large issues.
I guess the real question is, you're going to be leaving some in the building, and are others?
Maybe.
Are they? I'll say happy with that solution, or are they going? Is somebody going to insist that no, you go in, we want you to clean it all up?
Well, we're going to clean as much of it up as practical. You know, with any kind of decon work, even though this is a really ugly isotope, you get to the point of diminishing returns. You can throw a lot more at it and achieve very little.
I get that. That doesn't mean others can't ask that you do more. That's it.
Yeah, I understand.
Larry Powell, Cal.
Tyler?
It's my understanding that the heating and air systems are operational there, and the lighting is minimal and so forth.
Well, the lighting in the building's okay. It's just within the cells themselves, the lighting had become degraded and wasn't functional.
Okay. How long, guessing, is it going to take to get the building to a point that everybody's happy that the building is as clean as it's going to get?
We will finish up what we currently plan to do as far as physical work in the building in about the middle of FY20. And part of that is to go in to do another assay to determine, okay, what's left, how good did we do? And we'll do some limited assays as in process, just to kind of check on it. So then it will depend on how much of it we removed. When the analysts go do their work and we see what the results of the analysis are, is there additional work that needs to be done? There is material in, this isn't the only thing in that building. It's maybe a quarter or less of the footprint, including all the non-radiological ventilation stuff and everything else. The actinide billet line is in there. I don't know the levels off the top of my head, but it's neptunium, which is much easier to deal with. And then the PEF, the Plutonium Experimental Facility, and the old MET lab are in there. We did not re-assay those during this go-round. During the 2006, during one of the previous assays, I'm not certain if it was the 06 one, they did assay those, and the holdup in there is on the level of grams. It's not a lot compared to this. I mean, most of what is in the building is in cells 1 and 2. That's why we decided to tackle the puff cells first. And then when we've done all we believe we can reasonably do there, see where we're at.
So you're thinking that maybe within 5 years you may have the whole building completely clean. And where I'm trying to get with this is, once it gets to a point where you're comfortable that you've done all you can do in there, will you shut the power off, close the building up? What will happen after that to maintain the building as a safe
One of the
place?
things we're just beginning to talk about is a concept of, at some point, is it worth taking the building cold and dark, cutting the power to it? How much dark and how much cold? There's a lot of sheetrock in there. There's still some carpet. If you cut the HVAC, you could have problems down the road that has nothing to do with the plutonium. So we're just now starting to think about that, and I don't know at this point. I don't know where we'll end up on it. I don't know off the top of my head what the date is for the D&D folks to do something, because I think this will be done. I'm guessing, but I believe F area will be done probably as a whole area when it comes time to close it. I mean, when we get done with this building, the 6 when it comes to closing F area, the 600-pound gorilla in the room is going to be the canyon.
So Mike Michelanis, DOE. Larry, the short answer to your question is the campaign that Randy is briefing to you right now does not de-inventory the entire building. He mentioned there were other places of holdup of materials within the facility. The heating and ventilation system is one area where there's some deposits and a couple other places within the facility. The department initiated this activity in response to a recommendation from the Defense Board in 2012, which the Defense Board wrote to the Secretary saying this represented one of the more significant hazards on the site to the workers and to the public, and we needed to pay attention to it. So this project was intended to de-inventory this part of the building. We're still far from, Randy talked about fixes and things like that. We haven't even begun the negotiations yet with the state, discussions with the state and EPA regarding a final closure strategy. It'll be part of the larger F area closure plan.
Thank you, Mike. But the ultimate goal is to shut the building down completely and go dark.
Yes, of course. Whether we fill it, whether we demolish it like like they're doing at Hanford with the plutonium finishing plant, there's obviously hazards associated with that the department still hasn't, as Randy said, we are just beginning those discussions, and we're looking at the lessons learned out at Hanford to see whether that's really the right approach to use down here.
Thank you.
Mary.
Mary Weber Cab. Can you tell us where and how the materials that are being removed are being stored?
When they leave the 235F building, they'll be drummed and packaged for shipment. They will then go to our solid waste area and E area, where they'll basically be stored awaiting shipment to WIP. And I don't know all of what entails shipment to WIP as far as schedules, when they can do it. There's some amount of assay and things, additional assays that will need to be done prior to the shipments. So I guess the answer to your question is I don't know. Our objective is when it leaves the building, it's ready to go as far as we're concerned.
But are there materials that have been removed already? Because it seemed that you said you removed combustibles.
Yeah, that was just trash. I mean, it wasn't contaminated.
Oh, okay. Okay.
Yeah, when I say we removed combustibles, that was out of the rest of the building, not where the plutonium is. So I mean, there were offices in there, there were machine shops, the other facilities, some of the other facilities that I mentioned. There was a cafeteria in there that had it was full of particle board cabinets.
So there was nothing that had to be packaged for shipment out of that?
No, it was just, well, I mean, it was disposed of as waste.
Thank you.
Doug Howard Cap. Randall, the decontamination process, is that done every day?
In this facility or on
Right.
site?
In that facility?
No, we're just getting ready to begin it. Like in the next week or two,
Okay.
we will physically go in through cell 1 and start removing material.
And what type of manpower do you have to do that?
20 people, 5-ish, a handful on the crew. As you might guess from the pictures, there's a limit to how many people can work in there at once anyway. So you could get to the point where throwing more people at it isn't going to make anything go any faster. There's not a lot of space to work, but the 5 or 6 folks that I mentioned were involved in some of the TRU work that was done a few years ago. So they're very familiar with working through gloves, separating material, paying attention to sharps, punctures, things like that, because those would all be hazards we'd be very concerned about in this work.
Thank you.
Gil?
Randy, thanks a lot. I appreciate it. And I always hear you, I've heard you say a couple times, we can throw more money at it and we just can't go any faster. And I understand that. But, you know, Michael brought up the plutonium finishing plant, you know, and I mean, he said what we're going to learn from what they've done out there in Hanford. Are we following a similar path that they followed when they went to deconstruct, or are we reinventing the wheel here?
I'm not that intimately familiar with exactly what they've done other than they're tearing the whole place down. You know, when I went through the original description of the building, it's a big chunk of concrete. And the building itself is not contaminated. It's the processes within it. So, and a lot of that would depend on what we can negotiate with the state, with our regulators, what everybody agrees is an acceptable condition to leave there. But you could gut, like I said, the building's not contaminated, and this footprint is maybe a quarter of the building, and of that quarter, these cells are really what's contaminated. There's a level above this on the second floor that's ventilation equipment and electrical boxes and things like that that aren't contaminated. So there's a lot of things. I don't know where we'll end up because, like I said, that'll be a negotiated state, but I personally don't see any reason to even think about trying to remove the building. That would be very expensive, very difficult, and it doesn't buy you anything.
So, Mike McLean, DOE, you're talking, I think, Randy, what he was talking about was prior to them getting to the actual demolition of the building. Hanford did spend a lot of time de-inventorying vessels, removing a lot of the equipment. They had glove boxes and things that are analogous to what we had. This details are different, but the general approach for working within the glove boxes and what we're doing here with the cells is very similar. Yes, they went well beyond the scope of what we're doing here in the cells because they went and got the rest of the facility too in preparation for taking it down to the ground.
Was there, is what Randy was explaining, that the building itself is not contaminated. Do you happen to know if PFP was contaminated?
There were portions within the facility itself. I remember in '95 or so, '96, when I first joined the department, there was a exothermic reaction in a cell, in a tank within one of the cells that released a lot of material within the facility. So yes, portions of it were heavily contaminated. I just don't know to what extent.
And we're hoping at the end of this exercise we will decontaminate the cells to the point where there wouldn't be anything additional that would need to be done because cutting them up and taking them out would be difficult.
Oh, yeah.
It would not be undoable, but it would be difficult. The concrete, some of the concrete was put in after the cells were.
Okay. One of the concerns that I have in listening to Larry's comments, you know, is the goal just to turn off the power and walk away. And at one point, if you know, I've heard about 235F for 3 years. I mean, I know you've been working on it, and that's, thank you for saying the building's not contaminated. But that's one of the things is that from the state of South Carolina and DHEC's here, but I know how expensive it's going to be because I know Hanford has spent over $2 billion just on cleaning and trying to take down their building. But is that a good enough answer? I mean, is it okay just to keep $4 million a year spending on this?
Well, we'll know the answer to what we're able to get done with these cells for the part that I'm doing by the middle of FY20. Because we'll have done, we should have at that point completed everything that we can reasonably get done and have a new set of assays to tell us what's left in there. It could be, and I don't know, I'm just putting this, you know, it could be that at the conclusion of this, we have removed enough plutonium where the residual plutonium that's left would just need to be immobilized, and it may be, I don't know, fill the cells up with grout.
Okay.
But that's something that has to be part of that negotiation because that would be I think the term they use is an irrecoverable action.
Correct.
So you can't just go do that. Everybody has to agree.
That sounds like fun, getting everyone to agree. Thank you.
Bobby?
Bobby Williams, cab. On your slide on the work completed to date, you said the fire system and alarm, detection and alarm system were installed. Were there not any fire detection systems in the building prior to this, during the operations?
It didn't work.
Oh. Okay. It was there, but it just didn't work.
Mike
There were parts of a system there. It was not a system that would meet any of the standards that are out there running around today. So we installed another one as opposed to just trying to repair the bits and pieces that were there. It was easier and cheaper.
So, Mike Michelanis, DOE, let me expand upon Randy's comments there. Back when this facility was constructed, the fire codes were a little different. DOE's requirements for fire protection were a little different. When we went in to begin planning for this work, some portions of the fire detection system had degraded over time and weren't operable anymore. You heard Randy say they just kind of turned off the lights in the late 80s and walked away. So in some areas we could restore the operability by changing out detectors, pulling a little bit more cabling. In other areas of the facility, it was better to install entire new systems. The Defense Board's concern was that, and ours as well, was that if we were to have a fire begin in the facility, because it's not continuously manned like any other operating facility, is that we'd have to have early detection of fire or smoke so that we could respond to it before it became a full facility fire. So we extended the facility coverage to give us a better early detection if anything was going wrong in that facility. So we restored operability of systems that had degraded and extended the coverage as well.
Okay, thank you.
Dave, I just want to check, did you have any more questions? Okay. Dawn, close it out for us.
Dawn Gillis, Cab. This really isn't a 235F question, that's why I wanted to wait to the end, but it is an F area question. FA line, is it still got a lot of DU oxide in it? So it's still the same as it was years ago? Are there any plans of what to do with that in the...
Maxine Max to DOE. I'm not exactly sure if I'm going to answer your question correctly, but we have removed a lot of the DU oxide from the site.
I know that, yeah.
So the facility hasn't changed since, in F Canyon hasn't changed since you've been there.
Okay, so are there any, I mean, there was a lot of loose oxide in there. Is that facility being maintained to keep that oxide out of the environment?
We have surveillance and maintenance that we do on F Canyon and 235F and all of our facilities in order to maintain safety.
And is there any, I guess when F Canyon is decided what's going to happen with F Canyon, FA line's going to, FA line and B line will all be in the same plan.
So they try to do my understanding of the D&D is they will do it as an area because it's more efficient to do the entire area than just individual facilities within an area.
It's just that one's a little different than the rest of the area.
Yes. Mm-hmm.
Okay, I'm going to probably be asking that question before I leave again. Probably won't change, but.
Not the time you're leaving, no.
Yeah. All right. Thank you, Randy.
Thanks.
Okay. Where are we? Up next, we have Scott Nicholson, who's going to update you on or introduce a lot of you to Price-Anderson Act and NQA1. This is the first time we've had this presentation. This was at CAB request at the last January meeting. So, are you ready? Let's go for it.
All right, if I was doing a presentation on lessons learned, I would tell you all if y'all were flying and sitting next to somebody on an airplane and they're coughing and sneezing and they tell you, don't worry, it's allergies, don't believe them. So we'll get through this, so just bear with me if I got to stop and keep getting a sip of something to drink. So I'm Scott Nicholson. I'm the director for the Office of Safety and Quality Assurance. A couple of the areas that I'm responsible for are the Price-Anderson Amendment Act, or validation implementation of that program, and also NQA1. I'll try to tie these two programs together for you. Hopefully this is close to what you're asking for, but if not, I can hopefully answer your questions at the end here. All right, so just a few presentation objectives. Really just want to make sure that we understand the aspects of both PAAA, Price-Anderson Amendment Act, and the NQA program, which is implemented through what we call our Quality Assurance Program, which is a document the contractor develops for us that we approve, or develops for themselves that DOE does approve. I'm going to tie QA into the NQA1 portion also. Just want to make sure you understand the purpose of PAAA, the purpose of the program, what drives it, understand how QA helps reduce risk, what our expectations are, and how we perform oversight of our expectations of the contractor's work. All right, just some quick brief history here on the PAAA itself. The Atomic Energy Amendment Act of 1954, when that act was first authorized, this actually commissioned the government to establish rules, regulations, orders necessary to promote common defense, the safety, health, protection of the environment, down through that process. In 1957, the Price-Anderson Act, this is before the amendment was made, and as early as 1957, that was developed to provide prompt compensation for any nuclear incident that may occur with the work that was going on. It also provided indemnification to the contractors that were performing the work. It's basically insurance for the contractors. Since they were doing the work for the government, we were indemnifying them of any accident that may have happened or may have happened, excuse me. And then also to provide some broad financial coverage for damage, injury, if we had to evacuate an area. So all of that was contained into the insurance policy is what I would call it. In 1988, the Price-Anderson Act that was amended, and this is really where the rules for enforcement of the DOE safety rules came into place. So that amendment act said, okay, so if you're going to do this work, here's some of the guidelines that you're going to follow and how DOE is going to do oversight. Our government entities are going to do oversight of the work that you're performing. A couple other acts that went through there just because there was actually an expiration to the insurance policy, the indemnification process. In 1988, it was going to run out when they got a 15-year extension on it, which would have it would have ran out in 2003. That was another act that pushed it another year, and then finally in 2005, the Energy Policy Act of 2005 that pushed that indemnification out till December of 2025. So we'll be expecting another one, I'm sure, as we move forward. So really our purpose here is for the purpose of the PAAA is for the protection of the environment, health, and safety of the public and workforce. The insurance policy which indemnifies the DOE contractors. It does establish the quality and nuclear safety requirements, and then it provides DOE enforcement authority. And that enforcement authority is actually contained in 10 CFR 820. And what that does for us, it actually establishes the legal framework for implementing DOE nuclear safety enforcement program. But it also establishes some positive incentives for the contractor. So the really main crux of the PAAA is we want the contractors to do self-identification, to identify their own issues, early recognition, come forward when there are issues. So there are some positive aspects in the part of the rule where it does key on that. A couple of areas real quick. Timely self-identification of nuclear safety deficiencies, prompt and complete reporting of such deficiencies to DOE. If an issue did happen, go perform a root cause analysis to ensure that we prevent the issue from happening again. And then prompt correction of any nuclear safety issue that was identified. Our enforcement policy, what we were trying to maintain with that is, trying to be positive with the contractor and trying to reinforce that with them is that, there's a lot more of the individuals doing the work than there are of the government individuals doing the oversight. So they were in the best place to go identify issues and identify those issues to DOE because of just they're doing the hands-on work every day. We're trying to watch and do the oversight as much as we can based on the risk and the work activity that's going on. And then also it emphasizes on promoting the contractor timely identification, reporting, and correction of non-compliances. If y'all have ever had a presentation on the contractor assurance system, that's it in a nutshell. The CAS program for the contractor is just that, for their identification of issues, their self-reporting, ensuring that they're fixing the issues, ensuring the issues are not repeating themselves. Okay, as far as applicability, it does apply to all contractors and subcontractors and suppliers. Those two parts are real important. It's not just the individuals doing the work, say at the Savannah River site, but it could potentially be the subcontractors and suppliers that are providing work or parts and services for the actual work that's being performed at the site. All work must be accomplished with established quality and nuclear safety requirements as set forth by the contract. So when the contracts are established, we try to list all the regulations, rules, and that the contractor will be working to, so everyone's up front They know what the criteria is. They know what the cost is associated with it. Except for a law. If we forget to put a law in a contract, there's no excuse for that. It's like the speed limit sign is down and you know it's 55 through there, you're still going to get that ticket. So that does not prevent them from being able to use as an excuse if we fail to put a law in the contract. Nuclear facilities, including any location where work is performed, is what I mentioned with the first bullet, and then activities that can cause or contribute to nuclear or radiological incidences or potential for radiological harm. All right, just a few of our contractor responsibilities, and these should be pretty self-evident here. Understand and implement the nuclear safety requirements, the critically self-assess activities. We expect our contractors to have very rigorous self-assessment programs. They should be looking at themselves on a continuous basis. We do perform oversight of those activities to make sure that their self-evaluations are rigorous. Hopefully they are identifying their own issues. Doesn't mean that we're not going to find issues, but we're trying to prevent. We don't want to find the major issues. We want our contractors to find the major issues. And then to conduct work activities in compliance with applicable procedures. And again, assure the subcontractor's performance meets requirements. So it's on the contractor who hires a subcontractor to ensure that that work is being done to satisfy the criteria as if they were doing it themselves. All right, so some of the reporting criteria. So several areas of reporting criteria which can be the basis of a PAAA violation is what I have listed here. Non-compliances associated with ORPS reports, occurrence reporting and processing system. That is a program that comes from a DOE order that identifies issues, and it has a process for how those issues are communicated to DOE and has a corrective action program. So, for instance, if a maintenance mechanic is working on let's say they're working on this projector right here, and this projector is supporting some nuclear operation, and they fail to go enter certain conditions to ensure the system is in a safe condition prior to working on that projector, that could potentially cause an ORPS event, occurrence reporting processing system. So that's just a chain of events to where, hey, we messed up. Based on that, there's an evaluation that would be performed to see if it actually trips the PAAA criteria, and then we'll get into what that process here in just a second. Programmatic repetitive issues, if we have, let's say, our RADCON program, if we're continually seeing where individuals are not donning and doffing their PPE properly, their clothing, which protects them from contamination if they're working in the CA. Something as simple as that. If they're going in and out and they're continuing to have those issues and we're continuing to see those events, we'll go look to see if that's a programmatic breakdown. Maybe the training's not right. Maybe they're giving the improper training. So that something that seems as simple as something as that could actually trip you into the PAAA space because it does deal with health and safety of our workers. Security incident notification reports, intentional violation, misrepresentation. That's different than a mistake. If I'm working in a control room and I push, shut off pump A when I was supposed to shut off pump B, if that's just a mistake, that's not what that means. But if I intentionally do that and that can be proven, then that will get you into this space. Violations with high risk in the WHS is the worker safety and health plans. So it's those high risk activities which cause a significant injury or unfortunately potentially a death also. The computerized accident incident reporting system, that's our process for tracking injury illnesses. So if several employees got hurt on an event or one employee got hurt severely, it could trip you into that based on reviews of these programs here. And then, of course, employee concerns programs. Depending on what the employee concern was, what the outcome of that review was, could actually trip you into the PAAA space also. All right, so just a quick review of just the process itself. So what we're actually trying to do is just the identification of potential sources of issues to be screened for non-compliances. So that list that I just gave you earlier, that's part of what this process will do. It will go through and screen a lot of these events, and our contractor does have a procedure for this. If it's a certain event, it will check a box as they're filling the information out, and that will drive them to do what we call an NTS, the next bullet there, review of the non-compliance tracking system. That's actually the system where potential PAAA issues are logged in, or if we do have an event that did trip a PAAA space, it will go into this tracking system. That allows headquarters to be able to see the same thing that we see, and we also have a local tracking system on site also. If it is NTS reportable, someone in my office, I do have an enforcement coordinator. That individual is notified, and they ensure that it is entered into the NTS system and also the local tracking system. An investigation, a causal analysis is initiated, and this is all done by our contractor. We perform oversight of this. Corrective action plans are developed. Formally, these issues are tracked till closure, and then verification of closure. So as far as how we get to the closure, our contractor coordinator, who is counterpart with the DOE Fed that has this program also, they validate completion of the corrective actions. They identified in the report, they clearly identify in the report that, hey, we're finished with our corrective actions, we're satisfied, we don't think we're going to have any additional issues. And then my enforcement coordinator will go in there and go into the system and actually close it out. That starts another chain of events for us at that point right there. So the individuals that actually do oversight of this for DOE, we're actually doing oversight of the contractor. We have a whole other group in headquarters. It's called the Office of Enforcement. They're an independent group. There really are oversight, DOE's oversight. So the Office of Enforcement, it's EA10, Kevin Dressman, if y'all have heard that name before. He's in headquarters. He's the acting director for this group. So once the issues are closed, and actually prior to the issues being closed, Office of Enforcement can get involved if they think the event is, this really sparks their interest, or they want to get more information, or it's really a serious event. They will get involved well ahead of us completing our corrective actions and closing the issues out. And during this process also, the Office of Enforcement, they may initiate their own investigation. If they do decide to do that, they will notify the local DOE office. Our site manager, Mr. Budney, will get an official letter from them, say, hey, we're going to come down and look at this event, and we'll start gathering the information. And then we'll work with them, but they'll primarily be working with our contractors, getting the information from our contractors, but we just help make sure that we coordinate those efforts. There's a couple of outcomes from if Office of Enforcement gets involved. There's two results that can come from this. It would be a letter of enforcement. A letter of enforcement is almost like a warning ticket from a police officer. We've identified, we know there's an issue, we're going to give you a letter of enforcement, but we're going to continue to watch you, but there's not going to be a fine associated with it. They have the right to come back and open that letter of enforcement again later on and open up their investigation if they saw something similar to that event. And then we can get what we call a consent order. A consent order, there are fines associated with the consent orders at that point. The one thing that they're very good at coordinating with us, our manager, our associate deputy manager, Thomas Johnson, when we do award fee at the end of the year, these are the items that we discuss at the end of the year. So this would be where fee would be reduced. So when we get to the point to where if it's that latter part of the year, and we think if the Office of Enforcement feels like that there would be fines associated with it, they're pretty good with coordinating those efforts with the manager, and because they're not going to hit them twice with the same thing as long as there's substantial, or the fee reduction would be pretty much in line with what they were thinking. Now that doesn't mean that they won't fine them twice. They can, obviously, but there is good coordination in that effort. All right, so as far as the penalties themselves, there is an enforcement policy. So the rule that's out there says that we'll establish a program. The Office of Enforcement is the one that goes through and establishes what the fines are associated with the severity of the issue. And they're in three areas. There's three severity levels: severity level 1, 2, and 3, and they're tied to worker safety and health, nuclear safety, and classified information security. So if we're having issues in those areas, that's what will bin them into these severity levels, and then the associated fine with the severity of the event itself. As I mentioned, the earlier dates when these things were established, there is inflation, so they do go back in and look at these rates and what they're charging or what the penalty is. And about every 5 years, we just did this in 2015, 2015, which those rates went into effect 2016, so probably 2020 we'll go through, and Office of Enforcement will go through and take a look at those rates again to see if they're going to raise them based on inflation rates. All right, so this was the good thing. This is not in the QA slide because I repeated some of the information on here. Didn't catch it till this morning. But really, the only thing I was just going to point out here on this slide was really the last bullet was what I was talking about, the actual catch-up rate for the for the adjusted maximum civil penalty amounts. That was effective July 2016. So within the next 5 years, we'll be updating that again. And so summary for this one. So the rule, it was developed to govern the conduct of individuals involved in DOE nuclear activities. Establishing civil penalties designed to emphasize the importance of compliance and to prevent future violations. Again, self and early reporting is what we're looking for. If an event happens, and just going back to the fines, as an example, if I had an event that happened today, and let's say there was a $100,000 per day fine associated with that event. If it takes me 365 days to mitigate that event, that's a lot of money. So they'll be paying $100,000 per day per violation. So it could be multiple violations that are identified. The early reporting, self-identification, that does not mean that they will not get a fine, but the Office of Enforcement does take that into consideration when they come through and say, okay, if they do a consent order, here's what you're going to pay. If our contractors ignore it, or if DOE has to point it out to them and then it's ignored and not acted on, all that is taken into consideration. Since I've been on the site since 1992, I could say we've never had an issue like that. All right. So trying to tie these two together with the quality assurance program. So what does quality assurance do for us? So really we're looking for consistency, efficiency, and then productivity. Of course, there's various things that can hinder any one of those, and I've listed some of those on here. Some are human factors, procedural factors, equipment factors. So all this has to be evaluated when we go through and look at our programs and we look at our processes. So why is it relevant for us? It gives us that assurance and confidence that the people, processes, and implementation of those programs is going to match our performance expectations at the end. You've heard the term, you inspect quality into the process. We don't want to go at the very end and determine if something was done correctly. So this is all part of the QA program. We're doing that as we go along. And then just some examples of how we try to reduce that risk by the process by verifying some of these aspects, planning, design, materials used, the construction process, when we're doing conduct of maintenance, conduct of operations, all this goes into a good, sound QA program. And then each area is interrelated and checked, and there's checks performed along the way. So how do we get to here where we are right now? So 1954, only the government was able to develop or work with develop nuclear power. The Atomic Energy Act is what actually changed that. But when that was changed and allowing private industry to do that, of course, there was recognition of the hazards that are associated with the development of nuclear power. So as we move through this process, we get to 10 CFR 830.122. Well, before I get there, sorry, I said the laser here. So this area right here, DOE established a rule, which is 10 CFR 830.120. This is actually the Price-Anderson Amendment Act. So that's how in QA1, QA rule, Price-Anderson Amendment Act, this is how all this ties together. They talk to each other. So we have the rules, regulations, requirements, and then we have the penalties, and this is what happens if you don't do things right. So those two are tied there. So from there, DOE developed Order 414.1D, which is actually the criteria for a QA program, and this is what we have our contractors work to. So just some aspects of the quality assurance program, and this is actually submitted to DOE. Our site manager has to approve this document. It's submitted upon initial, if we had a new contractor that came in tomorrow, they would have X amount of time to submit us a new document that would have to be approved. And then annually, they resubmit it to us if there's any major changes. If no major changes, they just send us a letter and tell us that. But it does come through, and the DOE approval authority is our site manager. It identifies how work will be conducted, annually submitted, describes the basis for a graded approach. The graded approach is, for instance, if I'll use the projector again, if that projector is supporting a very critical program, then I will need that projector to work, pretty much 100% of the time. But if that projector is just supporting what I'm doing in here right now, if it didn't work, we'd probably just have to go start flipping paper, so it really wouldn't be that bad of a day for us. So the graded approach allows us to go apply what type of inspection criteria that we're going to use based on the risk of the process or the equipment that's being worked on. Their quality assurance program, it does go through the criteria out of 414.1D. We'll get to those in just a second, and how they're satisfying the criteria. It describes the program. It integrates the criteria into the safety management program systems like the RADCOM program, fire protection program, maintenance program, ConOps. It describes how subcontractors and suppliers meet the QAP. This is what I was talking about earlier in the PAAA part. Our contractors will describe in their QAP, if they're going to hire a subcontractor to do the work, it'll show the checks and balances of what that they will do to go ensure that our subcontractors are meeting their criteria also. It identifies the type of training that is needed, the Federal Technical Capability Qualifications Program for both QA, quality assurance, and the software quality assurance program. And then how NQA1 ties into this is that the DOE order has the criteria that describes the program. NQA1 is actually the consensus standards of how the work is performed. It gets down into a little bit more detail of a description of a training program, of a M&TE program. We'll get to that part in 1 second here. And that is the consensus standard that DOE adopted. We didn't have to adopt that. There's ISO standards out there. If anyone that has worked in shipyards and maybe nuclear power plants primarily follow NQA1. But there were other standards, but DOE chose to follow NQA1 as our consensus standard. Here, I won't go through each one of these, but just as you can see, in the order 414.1D itself, there are certain criterion in here, and in the quality assurance program manual that I was talking about just a second ago, our contractors will go through and describe how they're meeting this criteria. And this is, I won't say very high level, but it doesn't get quite down to, it's not a cookbook, it's probably the best way to describe it. It gives enough flexibility to where if contractor A does it this way and contractor B does it another way, it doesn't mean those ways are wrong. It just, those are the processes that meet whatever work it is that they're doing. Contractor A may have, $1 billion budget. Contractor B may have $1 million budget. You know, so the cost is associated with that on what type of work, and it's based on the type of work they're doing also. So just moving through these different criterion: documents, records, work processes, design, procurement, inspection and acceptance testing, and then management systems and assessment and independent assessments. Those criteria correlate to the, am I going too fast? Sorry, I know Dave, you're probably gonna have a bunch of questions for me. I can already look at you and tell. Sorry, thank you. So the 414.1D criteria, the NQA1 is the consensus standards. There's 18 subtopics in NQA1. So each one of these would relate back to one of these different criterion, maybe two of these criterion, multiple criterion they may apply to. And this is really the nuts and bolts, I'll say, of how the work is actually done. So this actually gets into a little bit more description, and this is typically what we assess our contractors to, are the NQA1 requirements. So we have 10 CFR 830, which is the big picture. This is the rule that says you will have a quality assurance program, and here's some of the big picture things that a quality assurance program will have. From there, it goes down to the DOE order 414.1D, which gives a little more detail than what's in the rule, a little bigger picture, but now we have to have a consensus standard on how we go implement the rule, the DOE order, and actually how work gets done, and that's why we chose, our NQA1 was chosen as the consensus standard for actually performing the work. So our evaluations are against NQA1, but the impacts of an issue against NQA1 could actually impact all the way back to the rule, just depending on how bad the program was implemented potentially. So part of our role with what we try to do, or what we do perform NQA1 assessments and audits. I have 4 individuals on the DOE side that are actually NQA1 lead assessors. They've gone through the training, they've been certified. Our contractors, of course, outnumber us in this area probably 5 to 1 that go through, as it should be in that area. So we will go perform independent reviews of the NQA1 program. I'm of the mindset, though, once I look at a program, unless I'm having issues, I don't need to go back and look at it a bunch of times unless there's changes or we're starting to see events that are happening, then we may need to go back and take a little bit deeper dive. But what we try to do is what we call shadow the contractor assessments. I can send one of my staff that's NQA1 certified to go watch what the contractor's doing. We'll look at their plan. We'll make sure their plan is similar to what it would be that we would do if we were inspecting it independently. And then we'll go watch independently them perform their reviews. That actually gives me two boxes I can check off. One, we can take credit for the review being done because we will be assessing the effectiveness of their review, and it also shows us the effectiveness of the contractor's review. You know, are they really doing a good job? Are they really digging and looking at what they should be looking at? And then we provide monthly feedback in all areas, but in QA1 in particular, that, hey, we evaluated this, we saw these issues, we'll look at what they've done. Just make sure they are good self-assessments or audits that are being performed, and then we report the information to them. I probably got us back on schedule. That was the end, I'm sure. Questions?
All right. Who's first? Let's start down here at the end. We'll go with Susan first, and we'll just come around.
Okay.
Susan Corbett, CAB. I actually have several questions, but I'll just ask one or two and then come back around me. So does the Price-Anderson Act cover transportation issues? Transportation of nuclear waste?
Yes, ma'am. It depends on really what the event was. So if the transportation issue was tied to a nuclear safety issue, then yes, ma'am, it would get evaluated against that if there was an injury associated with it. Now, it does get into Commerce Department of Transportation rules also, if depending on how it's being transported. But typically, yes, we would go do an evaluation of those events.
So is there a limit to liability per accident? For example, I just read there's been a train derailment in New Mexico What if that was carrying, DOE waste? Is there a limit to the liability for that kind of an event?
If it falls into the PAAA space, again, it would go by severity level, 1, 2, or 3, whether it was a nuclear safety, whether it was a worker safety and health. But that's, I'm not gonna say it's crossing the line a little bit, but when you get into commerce, when we subcontract something out and once it leaves our facilities, we're relying on Department of Transportation to get that there safely under the plans that we would develop for that.
So it sounds like you're saying Price-Anderson does not cover transportation accidents. So that's what I just heard. Is that what I heard? Maybe I didn't hear that right.
I'm probably saying both. I'm saying it probably depends on how we contracted it out to the individual that was moving the material, who was really in control of the material, what rules and regulations they're under. So probably my best answer for you at this point is to get you a better answer.
I was going to say, doesn't, for example, in a shipment of DOE waste, doesn't Department of Energy own the waste?
We do.
It belongs to the DOE, and I'm assuming whatever packaging is part of the DOE. So any accident that caused a failure of that, would that not be the responsibility of the DOE? So you can't answer this right now, I guess that's what I'm hearing. So the other question I had is, what are the limits to liability? Are there set monetary limits? Is there, because I know, for example, I think in a nuclear power plant, it's like, what, $12 or $18 billion or something. Are there limits to liability?
Yeah, there is, and it's based on contract amount. And I had that written down this morning, and I failed to bring it with me.
Okay.
I could actually get you that. But yeah, there is a limit that is established. They actually enacted that 10, 15 years ago, but it's based on contract value. I'll get you the exact words for that.
Okay. All right. I'll let somebody else go.
Okay. Let's come back around. Dan?
A lot to digest in what you've spoken of today. Kind of getting where the rubber meets the road for me. How are our current suppliers doing? Do you keep scorecards on their performance, and how well or how poorly have they rated in recent years?
Yeah, so there is actually a qualified suppliers list that our contractor does keep, especially for NQA1 qualified suppliers. And our contractors go out and validate every so often to make sure that their programs and processes. To tell you that we have 100 and out of those 100, 99 of them are good. This one we kick off the list. They do kick some off occasionally. But typically the process is rigorous. The suppliers know that's a lot of work for them. So they typically maintain their programs well, and we do validation of those programs. I should say our contractors perform validations of those programs.
Are you aware of any fines or penalties that were levied in recent years?
On those subcontractors?
Prime or sub?
For PAAA space, yeah, there have been. For our site, as an example, and I'm going to look at my boss there. I don't know if I don't really know the dollar amounts, but I mentioned the retaliation case, and this is stuff that's public knowledge you can go find. We did have a retaliation case that was upheld. A consent order was issued on that. We went into an operational pause a couple of years ago for nuclear safety issues. There was a fine associated with that. And I know we had a enforcement letter on an individual that hurt their shoulder. Once they got through with the investigation, they decided to pull that back. So 2 or 3 that I could think of off the top of my head in the last 5 years.
Not a regular occurrence.
Okay, yeah, no, sir.
Thank you.
Okay.
Dave?
Dave Abakas, CAP. Thank you for your informative presentation. So the Price-Anderson Amendment Act protects and potentially indemnifies contractors, subcontractors, and suppliers. What about those like DOE employees, EPA employees, Forestry Service, South Carolina DHEC, visitors? Are they under a different act, or would this act cover them also?
So they would not fall under PAAA space, but there are other programs that would protect a federal employee, for instance, if there was an event that happened, injury that happened. So PAAA was specifically written for us being able to go enforce rules against our contractors to ensure that they're following their nuclear safety rules. So then the big picture, it's not black and white between the two programs, but there are programs that do cover federal employees for if retaliation or if a whistleblower, we have an employee concerns program, which do get investigated the same way. If you're asking fines in that area, I'm not aware of any fines that would be associated with the government paying other than the list that you just identified, potentially them suing the government and winning. That would be one way I guess they would be able to do that, but it does not fall into that PAAA space as far as fines for those individuals. Tom?
Tom French, the cab. Scott, thank you for your presentation. It was very, very helpful.
Sure.
I just have one thing I was curious that you said something about coordinating penalties and award fee hit, because you could do both.
You could do both.
Yeah.
Yes, sir.
But DOE tries to balance those two. I mean, if you get a huge civil penalty, I know you're going to lose some award fee, but they don't make another big punishment in the award fee, or how does that work?
Yeah, and I don't want to make it sound like that will go, and the Office of Enforcement, at least the relationship we have with them, with the group that's there now, they are our oversight also. With DOE, they're an independent branch that comes in and looks and makes their own determinations. They're very forthcoming with, hey, here's what we're thinking, without giving us a dollar amount. But hey, here's what we're thinking. They'll send a letter to the manager. They'll have conference calls with us. We'll go through and they'll discuss it. During those discussions, we may bring up the fact that, hey, it's September 1st, it's the end of award fee. Yep, these are the same issues that we've been identifying, and we're going to deduct probably X amount from that. They take that into consideration if they levy a fine. Now, they still could levy the fine to the maximum extent. That's totally up to them, but they try to be fair with it because, the whole. Now, I would say if it's something that was malicious or they were trying to hide, if the contractor was trying to hide, I wouldn't expect any deduction for anywhere across. But if they were forthcoming, they identified it, they stopped, they try to take all that into consideration. Okay, sure. Okay. Jim?
Jim Gill, cab. In a fairly typical year, how many NTS reports do you have to deal with?
There are I won't say a lot of reports. There's a lot of screenings that are done that don't actually trip into the space. 10, 15, I can get you an exact number by year. I can go back 3 or 4 years if you want me to, and we can get you that number.
Just gives me an idea of volume that you're dealing with.
Yes, sir. It's not a whole lot. It'll just trip the criteria where the investigation is done, so it actually gets into that system, but it doesn't go any further than that. Like I said, I can only think of 3 actual events in the last 4 or 5 years that actually tripped into the PAAA space where it's a consent order or an enforcement letter.
Okay, and typically how long does it take to close one?
Good question. Not defending or deflecting the answer, but it depends on the corrective actions. So let's say I had an event that had 10 corrective actions. Some of those corrective actions may go out months, 6 months. And typically what will happen is they'll do an effectiveness review 6 months after the last corrective action has been closed. So we want to go back in and validate that, yep, your program is effective, you're doing well. And my coordinator will work with the line organizations, the facility rep, subject matter expert, whoever it may be. They'll actually go in and do a very thorough review and document the results of their review. So they could be open for as much as a year, maybe a year and a half, just depending on the extent of the corrective actions that were developed.
Okay. All right. One last quick one. NQA certification, you act as the certifying agency?
We have our chief engineer on our staff, actually works for our site manager, director of our site manager. He is actually our certifying official. So he has gone through the NQA1 school class. So yes, sir, he does that for us, and the contractors have their own.
Okay, and so the contractor can then claim NQA certification for you, which is transportable to any other facilities he might be working?
Yeah, so their certifications are, the contractor does their own certifications and DOE does their own, but they're identical. I would say they are transportable wherever they go, whether it's federal or contractor certification.
Thank you.
Okay.
Thanks, Greg Murray, CAB. Thanks, Scott, for an informative and important presentation and information. Jim beat me to my question, so let me ask it a little bit differently.
No, okay.
So, how many of these events would the average contractor have in a year?
Hopefully 0, but we know that's not the case. It's the willful, malicious events. I would say that would be 0. The ones that actually trip the investigation, my guess, not knowing what's going on with the other contracts, but I could go look into the database and get you that number. It would probably be 1 or 2 a year per, depending on the size of the contractor also. As you know, the work is pretty complex.
Right.
There's a lot of activity, and it doesn't take much to get you into one of these categories to where an investigation, or either at least they want to come down and look at what's going on.
That's sort of what I would expect, given how complex the work is. They could be well behaved to the nth degree, and still there are going to be times where there's just going to be a mistake, and it's going to get them into the system somehow. So thank you very much.
Yes.
Okay. Greg, or sorry, Doug.
Absolutely.
Just reading one, seeing the other.
That's a little more tan. Doug Howard, CAB. When document control, are we talking about classified documents?
For the different categories, or
I saw you had up there document control.
Yes, sir. They could be classified documents, but it could be something as far as procedures. Number 6 here. So if we have a procedure that we're doing a maintenance activity on, that's going to be a controlled document. It's going to have all the right approvals, the whole 9 yards. So this is the process that ensures that our contractors are working to the right processes. So if they didn't have that program and the engineer sitting at his desk and decides I want to do it this way today and write something and gives it to the maintenance mechanic, that's what we're trying to prevent. So it's a controlled program. So drawings, specifications, engineering calculations, procedures, manuals, all of that is maintained by a document control program. And it can be classified or unclassified documents.
Gotcha. Can you give us a maybe figure of what maybe 1 year past that you might have had violations in this area?
I cannot think of any area in document control that tripped an NTS event. So no, sir, nothing. I'll be happy to go back and look though. But off the top of my head, I can't think of anything that would trip into this area right here.
Great presentation. Thank you.
Okay, yes, sir.
Let's go down over here again to Narinder.
Narinder Malik Cab. Thanks, Scott, for the beautiful presentation. I have a couple of questions. First is, how many Price Anderson Act fines have been levied on WSRC, SRNS, and SRR?
WSRC, I didn't go back and look at them, but I would say for our M&O and liquid waste contractor, I know there's been 3 over the last 3 to 4 years.
So they were closed. Did they do their root cause analysis and?
Yes, sir. So they should be. I will say they should be closed by now. Again, it depends on the corrective actions. Now, of course, they can levy a fine prior to them resolving all the issues because they'll come in and do the investigation. We may have issues that are ongoing. The investigation team will come in and look at that and to make sure that the corrective actions that are in place are actually they're going to be comfortable with. So there could be instances where there could be some open issues that fines are levied prior to all issues being closed.
Coming back to NQA1, is site dealing with NQA1 2009?
Currently, we have implemented 2008, 2009. That is the current version. We just had an amendment to 10 CFR 851, the Worker Safety Health Rule, which potentially may bump us up to later revisions, but we're off evaluating that right now.
Based on your knowledge, what's the time limit one NCR needs to be closed?
We actually track that, and we do not like to see NCRs open greater than 180 days. We're actually down to about 20 right now, and some of those are associated with, let's say, a facility in 235F. It's in a room, and not saying there's one in there, but I'll just use that as an example since I saw Don look at me real quick. Yeah, no. But it could be in a room that we know we're not going to use that piece of equipment, but there's an NCR on a piece of equipment that's 10 years old. So we have been driving our contractor the last year and a half now to go figure out how to get rid of that NCR. Go make a change to your DSA, your documented safety analysis, to show the equipment's not needed. You can close the NCR out, but the numbers are actually driving down, so they've actually done a good job on driving.
The reason I ask, I know there are few NCRs in H-tank form for the electric poles and the saltstone watt number 4. But so that's why I asked question, because they were way over years old.
Okay.
Just a comment for NQA1 auditor. Once you are an auditor, you are audited for the life. Unless you want to be a lead auditor, you have to perform at least 5 audits and 1 audit every year.
If you need to come do an audit, let me know. We'll bring you up.
Thank you.
So,
I am an auditor.
I know, that's what I mean. If you need to keep that certification up.
Susan Corbett, CAB. So a couple more questions. Let's see. So is the contractor ever held responsible, or is this the purpose of this to protect the contractor from liability?
No, ma'am. The contractor is held responsible.
So the contractor can be held fiscally liable in certain situations.
Yeah. So the way the indemnification, my understanding, it gives them an insurance policy for doing work for DOE that the government would unfortunately have to foot the bill, but that doesn't mean we don't hold the contractor responsible for what they cause.
But the bill would go to the taxpayer.
Yeah, unfortunately.
Okay, so the contractor isn't really responsible. I mean, he might not get hired back, but they're not fiscally responsible, correct? Is that correct?
Yeah, for the indemnification process.
Great.
Yeah, the government would pay that, which is the taxpayer, and then the government would come back and fine the contractor, which the numbers will probably be, they probably wouldn't balance out.
So in case of like worker exposure, is that something that Price Anderson covers, or is that under a different?
No, ma'am, it would be. So that would be under the Worker Safety and Health.
That's Price Anderson, though, that would cover
definitely
that.
Yeah. So if we had an uptake, individual received more dose than they should have, it actually would trip that screen where an evaluation would be done.
Okay, and then if you had a larger accident that required some major cleanup, is that covered under Price Anderson as well? It
would be, and I'll say it should be. It depends on the cause of the accident. Was it, was it because we had bad procedures?
Right.
Did we not do something correctly? So all of that comes into play, and it's a very thorough evaluation.
So who determines? Is there a board that determines the compensation? What is it? Is there a filing system that goes on to determine how much the compensation? Who makes that decision?
The Office of Enforcement.
The Office of Enforcement.
Yes, ma'am. And Kevin Dressman's office, EA10.
Okay.
So they have their criteria, and they establish the fines based on severity, based on the event, and then per day until it's mitigated, they'll come up with a number. And I'd probably be naive to think that they just would, fine is $90,000. It took them 5 days to fix it. We're going to charge you $450,000. They may say $750,000. I'm sure they have criteria where they can extend what the number is, but we do have a baseline, or I should say they have a baseline as to what they follow, and they send that to us so we know what it is.
And I have one final question to y'all. The Nuclear Waste Technical Review Board, what is that relationship? Do they just advise you what they think is they make recommendations on all kinds of nuclear waste technical issues? Is that you don't have to follow what they recommend? You just take their advice. Their advice doesn't really hold a lot of weight. Is that what I'm hearing, or it does, or what is the relationship there?
Mike Michelanis, DOE. I'm only aware of the one report, at least since I've been the assistant manager. It's purely an advisory. There's not an enforcement action with that board at all, no.
Okay, thank you.
Okay, thank you. All right. Anything else from around the table? Thanks, Scott.
Okay.
Okay, before we cut out for a break, a couple of announcements real quick. If you haven't signed in, cab members, please do so that we can count you as present. Please also make sure that you sign your travel voucher, turn it in to Chelsea. When we come back, Pat Suggs is going to give you an update on the interim SALT program, and then we're going to go into public comment. A couple of notes about public comment. Please remember that it's comment period and not a question period. If you do have a question, we ask that you fill out the pink form on the table out there, and we can get you a response after the meeting. Please also make sure if you do have a comment that you'd like to give that you sign up outside so that we can allot the proper amount of time to you. Okay, with that, please be back in your seats at 2:45. Thank you. I've got most of you back, so let's go ahead and get started, huh? We'll let all the slow people drag in. How about that? Up next, we have the interim salt processing presentation and Pat Suggs.
I'm Pat Suggs. I work for the assistant manager for waste facility, and the solvent's recycled, it's reused. And then the decontaminated salt solution does go to Saltstone for low activity waste grout treatment. This is a really thrilling chart to me. You can tell I have a technical side, but SWPF's original target for decontamination, I should tell you that when we first started ARP MCU up, we had a design requirement of a decontamination factor of 12, and we were so pleased when it was operating about 150, and you know, everyone wanted more though, and SWPF was going to have 40,000. Well, we put the next generation solvent in and started operating it in 2014. And this is the SWPF design requirement. And around, you know, here we are at 65,000 for ARPMCU. This is just unreal. So we've learned certain things as we've operated ARPMCU. We learn a little bit more about the progression as filters start to increase in pressure drop and how far ahead we need to start planning to change things out. We've had a very successful run with ARPMCU. We've always found ways to try to improve our throughput. We're always shooting to get another greater amount out of this process. And so during the outages that just naturally occur, we've taken steps to try to find ways to either make a piece of equipment replaceable faster. During the melter replacement outage, we did several maintenance steps to make certain that we can try to get the best run possible this next year. We intend to operate ARP MCU right up until as late as possible until we start up SWPF. And we've had this question before, even after we disconnect ARP MCU from the transfer lines and we start up SWPF, we're not going to take any irreversible actions. It's kind of nice to have a backup plan, kind of a risk management strategy. So, you know, if we need to, we could go back and tie it back in. So during the melter replacement, we have monitors for vibration on our contactors. You see those in the upper right-hand side. So we just went in and replaced 3 that were starting to show some vibration. The extraction contactors are the larger V10 contactors. That's the same size that SWPF has in their extraction. And we did make some ventilation modifications. This was both to reduce personnel hazard, but also to make it a little bit faster to replace the HEPA filters on the ventilation. So one of the things that is implied, but you may not remember, is when DWPF is not operating, for example, when they went down for the melter changeout, they can't receive the radionuclides for ARPMCU because, you know, there's a limited storage at ARPMCU, and DWPF can't keep receiving radionuclides when they're down. They have to work that material off, putting it into cans. So ARPMCU did come down while the melter was being changed out. In the meantime, we made the improvements in ventilation and changed out the contactors. We have 2 million gallons, that's 2 salt batches of qualified feed ready for processing. We started back operating on May the 22nd, and everything's gone pretty well. Actually, that says 137,000, but we're up to over 141,000 right as of today. And we're currently in a minor outage to change out a filter on the solvent. And We have a challenging goal set for ARPMCU. We always set the highest possible goals, and so they're making that climb to get back onto the dotted line there, and they've done very well so far. So ARPMCU, to summarize, has really done an excellent job in processing salt waste over the last 10 years. We didn't anticipate we'd be operating this long, but we've learned a lot. We've used those lessons to provide those to SWPF. It gives us space management in the tank farms. It allows us to keep washing sludge batches so they can be feeding DWPF. So this is an important part of managing our space so that we can keep preparing sludge batches for SWPF. So we'll keep bridging that gap until the last possible moment until we can tie in salt waste processing facility. And it does help reduce the life cycle of the salt processing program, even though it's a smaller facility than SWPF. So are there any questions?
Narinder, start us off.
Narendra Malik. How are you going to manage the cesium contaminated cartridges from the GCC or process control skid?
So we will have up to 10 years. We have two ways of disposing of that ion exchange media. We could grind it up and put it into DWPF glass, but we're also going to look at possibilities for alternative disposition off-site, perhaps at some of the disposal facilities.
So if it goes to off-site, is going to be any radioactive contaminated landfill or where?
I don't actually know where we would go with it, but it'd be shielded. It would go to an authorized disposal facility, and it would be one of the major radioactive disposal locations.
Can it be disposed of at the site like melter number 1 and 2, or?
We haven't actually looked into that.
Okay, thank you.
Yeah.
Okay. Let's come around. Let's go to Dave Isley.
Dave Isley, Cap, thank you for that, Pat. Was he asking about the ticker?
He's asking, I think you're asking about the ticker ion exchange columns after they're loaded with cesium.
Okay, I had the same question, so
Yeah.
you haven't solved that yet, really?
Well, one pathway is to grind it up and put it into DWPF glass, but there might be something that's more cost-effective and doable, yeah. So,
how would that waste be classified?
greater than Class C, I am assuming. So we
Okay.
would have to, yeah.
All right, is that shielded canister, is that like a shippable certified canister?
It could be.
It could be.
Yeah,
Okay,
it
so-
would be put into a different
So there's
container.
there's some solutions out there.
Possibly. We hope there might be something that's cost-effective, more
I always
cost-effective.
like that word, hopefully.
Well, we have one path, and but it would be. We'll look for some of the others. Yeah.
Doug?
Doug Howard, Cab. Great presentation, Pat. On page 14, you have down there at the last paragraph, additionally, during the outages, MCU ventilation modifications were implemented to increase system availability and reduce worker radiological exposure. What's the difference now that you've implemented that and before?
So the ventilation that it's talking about there is in the area where the contactors are, which is a high radiological area, and they had some of the vents running near some of the tanks, pulling too close to the surface of the tanks. So they moved them away so it wouldn't evaporate that quite as quickly, and they cut, as you can see, they put some safer plug-in, plug-out HEPA filter changes. So it had to do with looking at the flow through the...
Right, but what is the, do you have a measure of the difference before as far as that radiological?
Like a number before and
Right.
after I've done.
Okay. All right, thank you.
Let's come back around and go to Don.
Dawn Gillis, Cab. To follow up on Narender's and Dave's comment on what you're going to do with the ion exchange columns, I'm a little concerned that a process is being put into place without a known disposition path for something as hot as that?
The known one would be DWPF.
So there is a facility
That's
that's
right.
being developed that can grind these things up and actually put them in?
DWPF could take the material.
But
we
is there
hope to find a different approach that would be more cost effective.
But is there part of this whole plan, how you're going to grind these things up? I mean, is there a facility available right now, or part of this program?
We have actually, you may have actually been working at the time, but we have done grinding in one of our tanks before. Several decades ago, they used to use ion exchange columns in some of the old style tanks, and the intention was, as the evaporators operated, if they didn't quite meet the decontamination that they wanted, they would run the material through an ion exchange column. But then they discovered that it actually was more cost effective just to drop the batch and start fresh if they didn't get the DF. But during that era, this is an older ion exchange column, some of that material was dropped into the tanks when it was full. So as part of cleaning out some of our old style tanks for closure, they had to break that material up, feed it to a grinder in tank 7, and then grind it up and transfer it into a sludge batch.
So that process is still available today to use?
It would be along those lines. It may not be tank 7 in that particular grinder, but we've done this before.
Okay, all right, thank you.
Okay. Charles, is that yours?
Charles Hilton, Cab. On page 6 of the presentation, it says that we've poured 4,166 cans of projected 8,000 plus cans, and we've only closed 16% of the tanks. Are we way off on a number of cans, or what's going on there?
So if you remember the hypothetical big tank, so sometimes when we're closing a tank, it's not this material that's filling the tank. It's some of this material that we have to get out. So there's not a direct linkage there.
Thank you. Let's come back around. Dave?
David Bacchus, Cab. A budget question, please. Is all of this funded in PBS 14C, the radioactive liquid tank waste stabilization and disposition? Yes, okay. Thank you.
Okay. Any other questions from around the table? Oh, Jim.
Yeah, not a question. Just a couple of clarifications. One is, yeah, we're very sensitive to waste without a path. So part of the agreement when we set this up with DHEC was that we identified that if an off-site vendor becomes available to receive this waste, within 5 years we will be shipping to them. So that was the immediate path. Then the secondary path is, if we get closer toward the end of the liquid waste program and that opportunity hasn't developed itself, that's when we go into the process as Pat was describing. We grind it up and get it into DWPF. So there's clearly a path out for that resin. We're hoping for a better opportunity between here and the time we have to execute that. The other thing I wanted to clarify was Narinder had mentioned about, can you dispose of the resin like you have done with your melters on site? Okay. Again, sensitive to some of those words. We have not disposed of melters on site. We have 2 melters that are stored, looking for a path for them once we get to that point in time, but we have not disposed of melters on site. Last note was, there is a little bit of TD money you might want to talk about for the ticker process.
Okay, yeah, that's a good point. So early on, since this is considered a prototype, we did get some TD money to help design and build this. And in fact, it's not as much as we'll be spending to dissolve the salt cake in tank 10 and execute the demonstration, but we're grateful that there was some support from headquarters technology development to help us do this. And it has a lot of interest other places. I know Hanford has a lot of interest in what our experience is going to be, so we've got a lot of curiosity from other locations in the DOE complex. And thank you, Jim, for clarifying for me. Is there another question?
Yep, Dan?
Yeah, Dan Kaminsky, Cab. Great presentation, thank you. Obviously, the program was a great success, far exceeded a lot of people's expectations. One of the things that was done while the melters were down was proactively replacing some of the contactors. And so the cab was made aware, I think it was about a year or so ago, about some premature failure of valves that were well below their expected life expectancy. Did these last as long as we originally projected them to last? And are we doing any sort of post-mortem investigation to see their failure mode and what we can do better?
Valves in the MCU process?
I don't think they were in the MC, I think they were in the...
Was it vibration?
Yeah, there's vibration because obviously everyone designs this stuff to last a certain amount of time.
Right.
And you certainly don't want premature failure whenever humanly possible.
So,
did these last as long as they should have?
So actually we can rebuild contactors, and generally what that involves is pulling out the vibrating contactor and putting in one that's already available and ready to operate. The one that's pulled out can be disassembled and bearings replaced.
So it's an easy maintenance item.
Well, easy being relative when you're talking about contaminated equipment, but we've certainly done it before. And back to the vibration monitoring. So we did have some monitors on the contactors just on top. And then after, I suspect, the event you were talking about, we added additional vibration monitors that are not online all the time. We go periodically and take readings and see what they...
Yeah, I don't think the two were related. It just was struck a memory that...
so we have two systems that monitor vibration on the contactors.
Okay, thank you.
Any more questions from around the table? Okay. Lots of times when we have time left over, it doesn't happen very often, we open the floor up to questions from the public. Do you mind?
No.
We'll see. Does anybody in the public have any questions specifically related to this presentation? Going once, going twice. All right.
All right, thank you.
Thanks, Pat. All right, now it's time for public comment. Is there anybody who did not get a chance to sign up, who wanted to sign up? I do have one person signed up already. Is there anyone else? Okay, Tricia McCracken, if you'd come up to the microphone.
I'm Tricia Carpenter McCracken. I live right here in Augusta, Georgia. I used to come very often to these meetings. I've been busy. It's really great to come back. I remember a regulatory person sitting by me saying, I come here to learn. I said, I do too. I don't know if that's good or bad. I have a little quote here I just want to read real quick. We're looking at the best of what America has to offer when it comes to technology and industry and education, said Colonel Patrick Sieber, spokesman for the Army Futures Command Task Force. That means we need to get to where these folks are. Apparently this task force had the assumption, strategy, that these priorities are only in big cities, a restrictive strategy. Perhaps a big network like Georgia and South Carolina, DOE, SRS, could be the best of what America has to offer in these strategic priorities. I've sent a protest to the General Accounting Office as an interested party protesting the City of Austin selection. I have a little newsletter, Georgia Carolina Courier, so I'm leaving that as a printed information, somewhat quickly done. This announcement came out like July the 13th. You have 10 days. I want to put on the record that I've had great difficulty. They asked for the contract number, and I've called Fort Gordon. I've tried to call Public Affairs. There is a line at the Pentagon in which they ask you, what is your question? So if you have a question in the world, there really is a place that you can ask. And I did call today. I don't know what kind of response I'm going to get, but I certainly have it on the record. I'm looking for the contract number to go with my protest. I learned most of the information about NEPA from coming to so many of these meetings, just like you do. interested people trying to find out about our government. There was an agreement between Fort Gordon and SRS, and I don't know how much your organization got involved, but that is one of the issues that I'm raising in my protest, that we didn't have a chance to document all the wonderful things about our area and the CSRA. Atlanta was a finalist, and I'm not sure how they looked at it, but I'm sure they did not include the network of technology that exists in our state to compete with Texas. The other issue I brought up was market research. I thank the gentleman so much that talked about contracts, because that is an issue I know very little, but I think there are many, many questions that I can raise in my protest. The Department of Defense hired a contractor, unnamed in any of their media reports, to establish how we're going to have our new Futures Command, which I understand includes nuclear designing weapons. Thank you very much for the opportunity to come and make this comment and to put things on the record. I think it's a really important thing, and I know y'all labor bringing yourselves here and sitting through these meetings, but we do really benefit from your questions. I know I do. Thank you very much.
All right, thank you. Was there anybody else, just checking a second time, who did not get a chance to sign up that wanted to make a public comment? No? Yes, yeah, we'll take that. All right. Thank you. And with that, Gil, are you ready to move into voting this afternoon? I am. Let's do it.
Everyone, if you haven't already, under your nameplate, there should be a, what do we call these? A clicker. For your voting. A quick little side note that just popped in my head. When we were in New Mexico, we discussed with all the other advisory boards, we discussed this, the way we do the voting, and they were amazed, the other boards. And I think that we have, what, 3 or 4 that followed our lead almost immediately. So we're trendsetters. Good job.
Good job,
support staff. We're going to vote on some closures for recommendations. The first one we are going to vote on is recommendation 351, Savannah River National Lab funding. I don't have the committees on this. If the committee chair wants to say anything about that recommendation.
Dan Kaminsky, Cap. Yeah, we thoroughly discussed this one, Gil, and it's on their radar to discuss that as future PBSs are created. We've included it, I believe, with our IPL information as well, our concerns about funding for the lab, and they have it under due consideration. It's kind of from, I think, what the real response was, you have to pick your poison. There's pros and cons going PBS and the way they do it today.
Okay.
So, but they look at it regularly.
Thank you. So we are going to go ahead and vote on whether to close this recommendation. If you press 1A, it'll be yes. If you press 2B, it will be no. And if you press 3C, I'll be mad at you. So 1 or 2. Are 7 and 12 accounted for? Carlos is not here. And Tom French?
Just do it.
So we're good? Okay. Let's, sensing everyone's voted, close the vote. Yeah, we already did. Wonderful. We have closed that unanimously. Thank you. Moving on to recommendation proposed for closure, recommendation 352, glass waste storage. Dawn, is this yours?
Yep. Dawn Gillis, Cab. Yeah, we discussed this during the committee meeting, and the responses came back as that they accepted all of the subparts. So we recommend to close it.
All right, we're going to open up voting for this same way. Green for yay, red for nay, and don't hit yellow. Okay. Voting is open. Is it, Chelsea?
It's not doing it.
Doesn't like any of them.
Do we need to reset this? Is it counting?
Oh, there's 19 votes.
Okay, has everyone cast their vote? Anyone not cast their vote? I'm going to go ahead and close the voting. Okay. We have, whoa. Okay, it closed. Thank you. We're recommendation proposed for closure. Recommendation 353, Defense Waste Processing Facility, additional failed equipment storage. Dawn, is this one of yours as well?
Yes. There were a couple of the recommendations that they could not accept because the, actually, I don't know if I actually own the recommendation, but it's in Waste Management. Did you own it? Okay.
Well, Narendra Malik Cab, DOE accepted the first recommendation that they should look for the funding, and the remaining two were not accepted because they are tied to funding, and it's a line item, so they said, we'll work on that when the funding is approved. So my guess is we can close it.
Yeah, I agree. It's more or less that it falls into how they do project management and acquisition. So they can't start design until they get to the right step to start design. So they can't start it right now and can't start construction until all of those steps are followed. So I agree that it's ready to close this one.
Okay. We're going to open the voting. One green for yay, red for nay. Go ahead and cast. And we're still not getting it to come up. Well, how do we have 24 votes? 30 votes, 31 votes.
Did everybody get a vote here?
No.
Okay, hold on, please.
Absentee ballots. We are going to add those to the vote totals. In case there's a tie, we'll read them off. But at the moment, I'm just
At
gonna
this
hold
point,
those
they
back.
wouldn't change any
Right.
of the votes. Okay.
What happened?
We're waiting for it to be reset, Narendra.
Yeah.
So what do we have when we have a lull? A sing-along? No.
No, let's not do that one.
I have the microphone.
Apologies, you do it.
All right,
Okay.
we're going to open the voting for 353 Defense Waste Processing Facility additional storage. People are already voting. 1 to close it, 2 to keep it open, and go ahead.
That's wild. That's a
And nobody voted.
Technology.
Yeah, this is true.
Need to turn the phone, turn it back on.
Yeah, do you want to do it just an old-fashioned hand vote for
We will go old-fashioned hand vote. One of the reasons that we discussed, and it's been discussed here, and it was discussed at the all chairs meeting, was the ability for people to vote with the other. So what we've noticed, and I don't know if you've noticed it in the votes, we've noticed that before we used to have unanimous votes across the board. Now we we don't have unanimous votes all the time, and we have 2 or 3 people that may vote no on an issue that we never used to get before. So that's one thing I really am encouraged by this vote system. I'd like to see people vote exactly how they feel, not afraid of what other people are going to think by their vote. So I'm a big proponent of this because I want you to feel free to vote the way you want to vote. Okay. So let's try it one more time. And it's not populating. So we may have to go to that hand vote, and you're going to feel uncomfortable if you're going to vote against.
Yeah, it's,
And it's
this
going
is
to
the first
29.
time it's had that response.
It's
That's
going to
crazy.
29. That's too many votes. All right, we're not going to use it. Well, yeah, but that's created an issue in the past before too. So. Yeah, well, the issue we had when we did the paper, it was yay or nay, and we still had a problem.
Because somebody didn't say yay or nay.
Right,
Said something.
right. So we're just going to go this way.
All right.
All those in favor of closing recommendation 353, Defense Waste Processing Facility, additional failed equipment storage, please signify by raising your right hand.
Please keep your hands up until I tell you you can lower them. $20 yeas.
Anyone that does not want to close 353, please signify by raising your right hand. Anyone wishing to abstain, please raise your right hand. Okay. The vote to close is confirmed. Now we're going to move into the votes on the draft recommendations. Ship low activity glass logs to WIP. Chelsea or whoever's running the computer, can you bring it up on the screen? We're gonna stay away from the
No,
electronic.
she's working on it. It's probably taking a second.
Okay. Can you scroll down? I'll read it in. Well, give me a little bit more.
Gil?
Yes.
This Don Gillis Cab. This is we added the second paragraph to the background. Talks about the ECA.
The new in these. Don, can you read it for me? I'm at an angle. Thank you.
The waste in the canisters is defined as high-level waste because of its origin and not its physical characteristics or health and environmental impacts related to this waste. The CAB has recently recommended that DOE look into redefining radioactive waste categories by the actual content of the waste, risk-based, versus the origin of the waste. The CAB realizes that there is a law defining this, and that can't be changed quickly. But as part of the actions related to that recommendation, other actions that will help to de-inventory the SRS of radioactive waste can be done concurrently. Along these lines, the Energy Communities Alliance published a recommendation to DOE in September 2017 titled Waste Disposition, a New Approach to DOE's Waste Management Must Be Pursued. It recommends basing waste classification, treatment, and disposal decisions on the actual characteristics of waste and risk to human health and safety rather than on the origin of the waste. That whole thing that they did supports exactly what we're talking about. That's why we added that in there. So the recommendations are: 1, determine how many of the currently stored glass canisters could be reclassified as TRU waste based on the actual curie and actinide content, risk-based. 2, determine how many future glass canisters might be so classified. 3, work with WIP to determine required actions to be completed to their facility and regulatory considerations to be able to receive and dispose of those glass canisters. 4, provide a conceptual plan for implementing this at SRS, including new facilities and transportation infrastructure that would be required. And 5, provide a tentative schedule as to when this could be implemented, assuming technical considerations only versus political.
All right. We discussed this yesterday afternoon. That was the time for discussion, so there is no discussion at this point. It's a simple vote, up or down. We are going to attempt to use the electronic voting again. Okay. So is it available to be used?
Call the customer service tomorrow. Let's do a hand vote.
So we will do a hand vote. All those in favor of accepting ship low activity glass logs to WIP, show by raising your right hand.
Okay.
All those opposed, will you show by raising your right hand?
Okay.
All those that wish to abstain?
Motion
The
carries.
motion carries, and it will be pushed through. It'll be sent to, pushed through, it'll be sent to DOE for their response. Sir.
Who is the energy Dave Isley, Cab, who is the Energy Communities Alliance?
They were they're a group that wrote a recommendation on the classification of waste. It's been emailed out to the entire board.
It's a group of people, and Shelley, correct me if I'm wrong, of individual members of the public from all of the different DOE facilities, areas of different DOE facilities that have come up with this. So it's a public organization. Is that correct?
Yes, it is essentially made up of members that represent local communities that host DOE sites. Yes.
And the report is what's being referenced here has been sent out to the entire CAB on 2 different occasions. So if you haven't received it, please get with James, and he'll make sure you get a copy of that. Okay, moving on to draft recommendation, TRU shipments to WIP. Don, I'm going to ask that you read this one as well, because this.
I don't think this one changed from what the hard copy was yesterday.
Okay, well, I still like us to read it because we're going to take a vote.
I'll read this one, but I don't think anything changed in it, Chelsea. During the multi-year WIP shutdown, February 2014 to December 2016, all shipments from all facilities had to stop. Before this delay, SRS was well on its way to total de-inventory of all legacy TRU. A portion of this legacy TRU still remains at SRS, as well as any newly generated TRU. However, a much larger inventory of TRU is being generated in the blend down of non-moxable plutonium. As we understand it now, very few shipments are planned annually to WIP from SRS from all TRU sources at SRS, legacy, newly generated, and PU blend down. Without the PU blend down, this would not be as big of an issue, but the PU blend down will generate a very large number of shipments that will be ready for shipment in the near future. If the number of shipments from SRS to WIP are not significantly increased in the near future, this inventory will grow at SRS. Recommendation: the CAB recommends that SRS work with WIP to accelerate shipments from SRS to WIP, concentrating on legacy TRU packaged prior to February 2014.
Thank you, Don. We are going to vote on TRU shipments to WIP. All those in favor signify by raising your right hand. All those opposed signify by raising your right hand. All those that wish to abstain, please signify by raising your right hand. All right. Recommendation passes. It will be forwarded on to DOE. We are now to a draft recommendation, restart the SRS INL SNF exchange. Don, I defer to you.
SRS stores 2 basic types of SNF, aluminum-based and non-aluminum-based. SRS has the currently operating capability to process the aluminum-based fuel. The reusable uranium is recycled back into power production, which is an off-site disposition. And the usable portions, fission and activation products, including any small amounts of plutonium in the fuel, are processed through the high-level waste operations and end up in glass, that should say canisters, ready for permanent disposal when it becomes available. Regardless, glass canisters, gotta change that one too. Oh, did you get that one? Okay. Regardless, glass canisters are far superior long-term storage form compared to fuel stored in water. SRS does not currently have a means to process the non-aluminum based fuels. Dry storage is not a means to process or disposition fuel off-site. It is simply another means of storage. However, INL has currently operating means to dry store non-aluminum based fuel, but not a proven capability for long-term dry storage of their aluminum-based fuel, nor can they process these fuels. Back in 1995, DOE's Record of Decision 1995B for the spent fuel management programmatic EIS included consolidating spent fuel regionally by type. The ROD stated that SRS would store all aluminum-based fuel and INL would store all non-aluminum-based fuel. Under this ROD, SRS would ship its non-aluminum-based fuel to Idaho, and Idaho would ship its aluminum-based fuel to us, to Savannah River, referred to as the SRS INL exchange. After several modifications to this ROD, none of which deleted the option of the exchange, a new ROD in 2000, DOE 2000B, reaffirmed the exchange but was subsequently put on hold. In 2006, DOE approved the mission need statement, which is the first step in defining a project through project management implementation for processing all of the SRS aluminum-based fuel through H Canyon. This project included implementing the SRS INL exchange and, if implemented, would have had the L Basin totally empty and ready to decommission by 2019. This project was never implemented. H Canyon is now successfully processing aluminum-based fuel from L Basin. This begins the inventory of L Basin. It's time once again to implement the SRS INL exchange so that SRS can de-inventory the non-aluminum-based fuel from SRS without having to build additional multi-billion-dollar facilities that would also need to be decommissioned in the future, dry storage facility. Recommendation, the CAB recommends DOE implement the exchange.
All right, thank you, Don. We are now going to vote on the draft recommendation, restart the SRS INL spent nuclear fuel exchange. All those in favor signify by raising your right hand. And please keep them up so James can count.
Okay.
All those opposed signify by raising your right hand.
Okay.
All those that wish to abstain, please signify by raising your right hand. All right. Motion passes. This recommendation will be forwarded on to DOE for their response. And James, I will throw it back to you.
All right. Congratulations, everybody. That's a lot of good work today. But we're not quite done yet. So yesterday you guys brought up, Chelsea, can you drop this and bring up that slide? Joyce, you brought up the idea of talking a little bit about committee scopes, specifically around FDSR. I know there's been discussions after that, kind of broadening it. We talked about it a little yesterday. We have some time, so let's continue that discussion now and see what you want to do with these committees. Joyce, I'm going to let you introduce the topic since.
Hello. So we are the Citizens Advisory Board, and as such our purpose is to provide the Department of Energy with recommendations and advice upon their requests on environmental remediation, waste management, and related issues. Our work is to provide meaningful recommendations to the Department of Energy. Therefore, our committees and their work plans should reflect this. Some presentations are interesting, but can they generate a meaningful and needed recommendation? This is kind of at the heart of my concern because since I've been here, which this is my 1-year anniversary meeting, the committee I'm on hasn't generated any recommendations. And I did some research last night and found that committee work historically has seemed to wax and wane. We're on, 354 recommendations at this point in 22 years, which averages out to about 15 or 16 a year. Some years there were less than 10, and some years there were over 20. So, I mean, things are fast, things are slow. Some years certain committees didn't offer a recommendation. So maybe this is just the natural waxing and waning of our work, but I think that it is prudent to consider the fact that the 4 committees we have in place now have been in place since 2004, and I looked up last night, before the ones that we have now, there were 5 other committees that kind of came and went from the genesis of the CAB until 2004, and I don't know what they were because all they were the acronyms, but maybe we can find that out and see if some of their work that they were doing then might be prudent now as opposed to what we're doing with our committees. I've lost my notes. Come on. do the thing. Technology's wonderful. So I guess what we need to ask is, do the committees, as they are now, address the work scope of the Department of Energy organizations they are meant to serve? And if not, how might we realign our committees and their work plans in the coming year to meet the needs of the Department of Energy organizations? And I'd also like to add, because this was a big aha for me, and it might be why recommendations aren't getting generated. Budgetary costs, I don't think, are our concern, because even if our recommendations are not approved, those recommendations serve as primary sources as to the needs of the Savannah River site as defined by us, the citizenry, and as such, those documents may serve as evidence of a need at the site, which may affect budgetary considerations whenever it goes before Congress and the Senate. So I think, I know I have not made recommendations because, there's no way to pay for it. I need to stop with that. So that's my 2 cents, and I'm going to open up the floor to the rest of you to discuss.
So, Don, your card went up first. So we'll go to Don and then Larry and then Dave Isley.
Dawn Gillis Cab. One of the things that I just realized today is there are a lot of facilities out there, major facilities, that are not owned by the disposition group because the disposition group doesn't have any money to do them. Big one in question is F area. F Canyon, A line, B line, the whole kit and caboodle. So if you ask Nuclear Materials, all their job is to maintain that facility until it gets turned over to D&D. So they're not doing anything to do actually D&D. You ask the D&D side, and they don't own the facility, so they're not doing anything with it. So when my comment on that was, from the CAB viewpoint, DOE is DOE. Okay, somebody's got to take responsibility for what's going to happen with these big facilities. So from that viewpoint, maybe the facility disposition group, this is all brand new information I just came up with after our discussion. So your comment made me start thinking about it, which is part of the good thing right there. But maybe taking a little bit more broader view than just what Avery says she does. Okay, the other option is going ahead and disbanding this committee, putting those requirements into the other committees so that Nuclear Materials would own the Nuclear Materials CAB committee would also own the deactivation of the facilities that have had nuclear materials responsibilities over the decades, and then Nuclear Materials covers the pushing to get the deactivation or the actual decommissioning of these facilities done. So it still could go either way, but there is a bigger picture here. And I know about F Canyon. I'm not sure about everything else. I know P reactor and R, is it P and R have been completed, right? Totally deactivated. And and obviously K and L are being used, but and I think C somewhere in a limbo in the middle there. But anyway, there's F Canyon, and then there are probably other things on site too that I can't remember. So so that kind of muddies the water a little bit more.
Yes, thank you. Joe, I wouldn't be too disheartened that you haven't had any recommendations. I think it is kind of cyclical. I know that Nuclear Materials Committee is like a roller coaster ride. Sometimes we've got a ton of recommendations, and sometimes we don't have any for a long time. I think your committee is an important committee, and I think it should stay on as it is. One thing that I think might be helpful is if you could, it's a personality thing. Some people, and I'm one of them, don't feel comfortable putting a recommendation out there. Dawn feels real comfortable putting it out there. But maybe you could look around the room and see people that are good at making recommendations, and see if you can recruit that person to your committee. They can be on more than one committee. It might be helpful to have, I don't know if you would want to require committee members to change committees from time to time, but I think a lot of it has to do with personality. But I do think that your committee is a very important committee, and I think it does a good job, but I just don't think the timing has come along, and I think it will. I think the site is, what, 60, 70 years old now, and it's getting older by the day, and I think as time goes on, your committee will be more and more important. Thank you.
That your comments echo a number of CAB members have come up to me since this topic was introduced. And your comments echo a lot of what I've been hearing, is that maybe it's not the committee that needs to disband. Maybe we just need to look at what the scope is and where we're going with it. Dave.
Dave Isley, CAB. I'm the new guy on the block, so I don't have a lot of experience, but I have some observations. Same thing as Larry. That you don't have recommendations within the last 2 years, that doesn't mean you're not important. I think your committee needs to ask yourself, are you relevant? Is your interaction with DOE helpful to the community, helpful to your committee? And that to me, that's much more important, is you feel like you're accomplishing something, and your committee members, rather than the number of recommendations. There's no scorecard that I know of, and there shouldn't be. That's it for me.
Because sometimes you just look at the activities that are going on, and you don't have a new suggestion for them. They're doing what you think they should be doing. Narinder?
Narinder Malak, CAB. I strongly believe that we need to keep this committee. There are a lot of activities coming up. We have no knowledge right now. Oftentimes in Savannah, we talked about infrastructure. I have talked to Avery, and she said there are issues, but she's trying to get the information. Once we get that information, we will be writing some recommendations to DOE for infrastructure development. On the other hand, as we know that facilities aging, there will be a lot of decommissioning going on. So once those projects are taking place, like F Canyon, we will have a lot of recommendations at that time. So my suggestion, my personal opinion is that we should keep this committee. Thank you.
Okay. We'll go to Greg next, and then I'll get you, Joyce.
Okay. Greg Murray, CAB. Another thing to think about, and maybe from even a broader perspective, is I don't know that the number of recommendations generated is necessarily proper, or at least the only metric that should be used to measure the quality of a committee. For instance, 2 of our presentations today were requested by this particular committee. Now, again, this isn't necessarily specific to this particular committee, this comment, but it may be something that we as a CAB want to think about in terms of how we think about a committee and what its contribution is.
Joyce.
Okay, I feel like perhaps I have misrepresented myself. It is not my desire to dissolve this committee. I do not wish to talk myself out of a job. But I want to see all of our time utilized effectively. You're correct. We did have 2 presentations requested by my committee that were put in my work plan. That work plan was generated by what was brought to me by Avery, and that came from what whoever above her told her to bring me. Now, my question as I look at my work plan going forward is, are these relevant topics that can generate meaningful recommendations? And I think a lot of the stuff on my personal work plan is updates on things that have already had recommendations given to them. And yes, it's great to have an update, but I don't need an hour for that, because I'm not going to probably not going to recommend anything further. I love Dr. Rhodes. I don't need an hour on hogs. What am I going to recommend to that? We heard that last year, and there was no recommendation. And it's great to hear about the hogs, but is there something like infrastructure that I could have had a presentation on that would have generated a meaningful recommendation to do with getting our infrastructure worked on. That's my concern, and I think this is broader than my committee. I think this is all of our committees. Then that's why we're having a full board conversation. Are all of our work plans generating the information we need to create meaningful recommendations? And I don't know. I just know that in the year I've been here, I've tried. I've wanted to write a recommendation, but I have not been presented a problem that I personally could wrap my head around enough to compose one, and no one else on the committee who's been here longer than me has done so either. So that leads me to wonder, is our work plan in line with what the department needs to generate recommendations? I think it's a great committee, and it's going to look really bad if we get rid of it because it says we don't care about facilities dispensation and site remediation. That's not my goal. My goal is to make our time meaningful here. So,
Michael.
Mike McLean, DOE. A couple points I want to share that came out of the executive committee meeting discussion. And I'll start first by saying the department doesn't have a desire to abolish a fourth-year committee or not. So the comments I'm making are purely to inform the CAB of some of the points that were made. If we wanted your committee, if we no longer saw a need for advice on that particular area, we would be in a dialogue with the chair to make to restructure the CAB. But a couple of the points discussed in the executive committee meeting were the metric regarding recommendations is a valid one. That's what, as the deputy designated federal official, my designated federal official up in Washington is looking at the kinds and the number and the significance of the recommendations that are made by all the advisory boards. There are a couple boards across the complex that only come up with one, maybe none, maybe two recommendations a year. Now, we're the only CAB that has 4 subcommittees. Most other CABs all have just one board, and they entertain all the subjects. Like my DFO has had discussions with me over the last couple of years of why we need 4. I've explained it, and he's happy with what we're doing. For those CABs that only have 0 or 1, 2 kinds of things a year, he's questioning whether they need to meet as frequently, because in those sites the work is winding down, the environmental remediation cleanup is nearing completion, and once you've got remediation fixes in place and the EPA and state and regulators are all happy and we're marching down to closure, there's not an awful lot of it's pretty much just marching through the steps then. So the significance of the CAB and the frequency they need to meet does change. That's the nature of the dialogue he's had. That's not here at Savannah River. We've got a lot of work still to do, and he hasn't. I share that with. That is a metric that's being looked. When Joyce brought up the discussion that she had with Avery, and she questioned objectively herself, she noted that, hey, my CAB committee isn't really generating a lot of things, and that prompted a discussion around the table that, well, a lot of the kind of work that her committee looks at is in the implementation phase, the part where the public interjects in environmental cleanup and coming up with action plans, et cetera, are with the state and EPA well in advance of doing any field work. And some of those areas don't lend themselves well to the CAB. Now, there are things that Amy, system manager, I did want the CAB's opinion on. For example, the annual site evaluation, wanted the CAB's feedback onto the, but not maybe in the phase that we're. It's entirely possible that there may not be enough to talk together. We put the actions on it that the department wants feedback on. You asked a very important question. I need to go back and talk to Angela from the CAB, and we need feedback from. If there isn't, then we do need to look at how we restructure some of those. What the committees are looking at and the topics on it. So I think this is a good discussion for yourselves to have, DOE, that we need to have impact, you need to have your feedback on. So I wanted to share a little bit of that dialogue that happened in the room and some of what I'm going to have to do now and go back and talk to my counterparts. I'm not making a decision here. I'd really like to hear what you all think about it, but I did want to add that to the topic here.
Thank you. Don?
Don Gillis, General People, even though it's not something, well, we did actually have a recommendation on what can we do to help pollinators on site. I think that was the last recommendation out of the committee. But so some of these things are things that the public wants to know about. So it's still important, even if it's not something that's going to immediately so, we need to generate a recommendation about that. But, I do have one in mind that I'll talk to you about. I'm getting more and more to saying, yeah, I think the committee is a worthy committee, and it's got a lot of things. The infrastructure one is a really good one that needs a lot more input on the infrastructure side.
Narendra?
Narendra Malik, CAB. I think you mentioned the hogs. I had it was dead. But I think wild animals, they even do the turkey count to the public. I'm thinking it is possible that we may be able to write a recommendation on that, but talk to us. So therefore, I think, get more information and present the recommendations. Thank you.
When I go to the points of contact and ask for the work plan topics that they've discussed with their AEMs, we asked this year a little bit differently. Maxine can probably tell you. I said, what is it that your organizations want input on? That's what the board needs presentations on. And then it in line with that. And if you don't feel like it does, maybe we haven't met that bar, and you need to let us know that. Yeah, Greg.
Was there something, doesn't have to be formal in some sort of recommendation?
Formal.
No, please.
And I just know that whenever Avery and I put it together, it was, we had this discussion when we were putting this work plan together about whether or not our work is important, but I wonder if there's redundancy. So, and as to maybe part of my frustration, if the department wants input on infrastructure, why was that not on my list for my work plan in the first place? Because then it could have been in the work plan.
I think that's something that we're definitely going to go take a look back and see what we're going to do, because I have that request from you in email now. It's going to go to the next post-cap meeting for sure. Narendra?
I mean, that seems to be everybody's biggest push right now, and I don't know, I know my committee didn't have anything about infrastructure in our work plan discussion, and I don't know if yours did or anybody else's, but I mean, that's the big push.
Okay, let's, your passion is unheralded. And one of the things, because you're so passionate, and after 1 year, my head was spinning. I didn't have a clue what was going on, and I didn't understand. Part of your frustration is because I don't think you've seen. You don't think you see how everything works together yet, and I don't know that you could. So I understand. I sense your frustration, and I feel your frustration. Infrastructure is a big push right now. Entire CAB, I've asked the committee chairs to recommittee. So that's where you're getting that. You're getting it from the executive committee, and you're getting it from me, asking you to focus on infrastructure. Avery's invaluable as a point of contact. All our points of contact are unbelievably important to us. And one of the things that I've learned as a committee chair was I had to learn how to work with my point of contact. And to ask it, because you can and be this thoroughbred that you want to be, but you're just out. I mean, in respect for I was listening to the presentations that you recall. Kathy's going to come to your committee meeting, and out of it, you brought a great recommendation to your committee today. Don't do that. I was like, ding, ding, ding. We have a huge recommendation out of your committee. You have, with all the committees, you have these discussions with your points of contact, and you also obviously very pumped up about NERP and the National Environmental Research Park. But I know those things, and I get them.
I think that's great, Gil. It is hard to remember. It's only been a year, for real? Wow. Other comments on this? The whole cab's behind you.
Of that ad hoc committee, but that ad hoc committee was made up of this committee having read or to discuss for closure as if this was the committee that sponsored it, which it technically is.
Absolutely. We'll add that to the agenda.
Well done. Been a good 2 days of meetings. Appreciate everyone's involvement. Appreciate the discussion. I don't know if you noticed the cameras moving around all the time. That matters. The sound, the AV, the work at the actual meetings is phenomenal, and I thank you. I thank you. I know there's not a lot of interaction sometimes with the cab at large, but I have a lot of interaction with James throughout the month or two, and James does a ton, and I know Chelsea does, and I know Delisa does, and I know Frederica does, and I know Chelsea. I know you all just do a ton of work, and I don't want to belabor it, and I don't want to embarrass you, Frederica, but thank you, and I also want to thank the presenters. They get up and they give us these presentations, and they're great. And we think it's just something they put together and they step up and they come in. No, they spend a lot of time on these presentations. They put thought into them. Let's not take our presenters for granted. I don't think we do, but let's not take them for granted. Also want to thank our points of contact, even Zachary Todd. I mean, they're really good. Although if you've had any situation, we'll call you or we'll get in touch with you. And the reason I picked on Zach is I had a question this last week, and Zach and I had a nice little conversation, and he helped me out. So, and DOE, thank you very much for everything that you allow us to hear, allow us to talk about. Jim and Michael, the DDFOs, I can't thank you guys enough. And then Eleanor and Bobby, and we sat down and we talked about new cab members, and we talked about time commitment. And y'all give a lot of time, and I thank you. I mean, we just spent a day and a half here in Augusta, discussing issues. We have committee meetings on the off months. We spend time. So I want to thank each and every one of you for your service, and I hope you all had a great summer. I hope we go into fall. Next time we'll meet, we'll be in Columbia, South Carolina as a full board. That's the first time I remember being in Columbia. Well, first time in my tenure. It's been a while since we've been in Columbia, so I'm excited about that. But we do have the committee meetings coming up. We had some strong presentations, and I look forward to hearing the committees and see what comes out of those. That's all I have, and you want me to close out? And with that, we close this meeting, and we'll see you at Columbia in September.